Hello, ma'am.
Hello, ma'am.
Ma'am, I'm audible?
Yes, ma'am.
Okay, ma'am. Thank you.
Hello.
Hima
Hello?
ma'am, Hima ma'am.
Hello?
Ma'am, I'm audible.
Audible, ma'am.
Am I audible?
Audible, ma'am.
Okay,
Yes,
ma'am. Thank you.
Hello.
Hey.
పెట్టుకో అమ్మా.
Hello, Rahul sir. Am I audible, sir? Rahul sir.
Yes, ma'am, you're audible.
హలో మ్యామ్.
Good evening, sir.
నా వాయిస్ క్లియర్గా ఉందా మ్యామ్? నా వాయిస్ ఎలా ఉంది? ఏదైనా ఎక్కువ
ఇనిపిస్తుంది సార్. ఇనిపిస్తుంది సార్.
ఇట్స్ ఫైన్ రైట్?
Okay, sir. We'll start in 2 minutes, sir.
ఓకే మ్యామ్, ఒకసారి స్క్రీన్ షేర్ కూడా చెక్ చేస్తాను ప్రజెంటేషన్. సార్ చూడండి మ్యామ్, నేను స్క్రీన్ షేర్ చేస్తాను ప్లీజ్.
సార్ గిరి సార్ స్క్రీన్ షేర్ ఆపేస్తే మీరు షేర్ చేయొచ్చు సార్.
ఓకే ఓకే మ్యామ్.
I'll just give an మీ ఇంట్రడక్షన్ అయిన తర్వాత మీరు చేయొచ్చు.
ఓకే అదే మ్యామ్, ఒకసారి ముందు చేసాను సార్.
ఓకే సార్, ఒకసారి చేయండి సార్.
ఒకటి ఆపమని చెప్పారు, అది ఎక్కడ ఆప్షన్? వ్యూ ఆప్షన్స్.
మీరు మీ కోహోస్ట్ ఇచ్చాను సార్.
కాదు మేడం, ఒక ఆఫ్ చేయమన్నారు కదా, అది ఆప్షన్ ఎక్కడ వస్తుంది?
మోర్ అనే ఆప్షన్ ఉంటుంది సార్ అక్కడ.
వ్యూ ఆప్షన్స్ లోని
మోర్.
గుడ్ ఈవినింగ్ సార్.
గుడ్ ఈవినింగ్ గిరిధర్. ఎక్కడ నేను స్క్రీన్ షేర్
Sir, you
చేసిన
can share the screen now, sir.
ఓకే.
గుడ్ ఈవినింగ్ రాహుల్.
హలో సార్, నమస్తే. ఎలా ఉన్నారు సార్?
బాగానే ఉన్నాను రాహుల్. ఐఎమ్ డూయింగ్ గుడ్.
థ్యాంక్ యూ సార్. సో డిజేబుల్ అనోటేషన్ ఫర్ అదర్స్.
Yes, sir. Disable
yes, sir.
annotation for others.
డిసేబుల్ చేసేయండి సార్.
చేశాను మేడం, ఇదే కదా ఇక్కడ
yes, sir.
Yes, sir. That's it, sir.
ఓకే, ఒకసారి స్క్రీన్ షేర్ చెక్ చేయండి.
కనిపిస్తుంది సార్ మీ స్క్రీన్. విజిబుల్ సార్.
ఓకే.
A very good evening to all the participants. Welcome to the day 3 session 1 of our ATAL FDP, where we continue our journey on sustainable practices and innovative trends in civil engineering. We are honored to have Dr. Chiranjeevi Rahul, our senior lecturer at Middle East College, Oman, to speak on construction 5.0 BIM driven innovation and for a sustainable built environment. Sir, we warmly welcome you to the session. Before we start, I now invite our faculty colleague, Mrs. M. Himangeshwari, Assistant Professor, to formally introduce our eminent speaker to the audience. Over to you, ma'am.
Thank you, ma'am. Good evening, everyone. It gives me immense pleasure and pride to introduce our eminent guest and today's speaker, Dr. Chiranjeevi Rahul Rolakanti, distinguished academic and professional, my guru, mentor, and a true inspiration in the field of civil engineering. Dr. Rahul is serving as a senior lecturer in the Department of Civil and Mechanical Engineering at Middle East College, Muscat, Sultanate of Oman, since 2015. He holds a PhD in civil engineering with master's degree in construction technology and project management and soil mechanics and foundation engineering. He also earned a postgraduate certificate in academic practice with distinction from Coventry University, UK. With over 13 years of rich academic experience and a year in the construction industry as a quantity surveyor, Dr. Rahul blends academic excellence with real world expertise. He is a chartered engineer recognized by Institution of Engineers, a member of Chartered Institute of Building, and a fellow of the Higher Education Academy UK. His remarkable research contributions include 5 patents, over 30 publications, and 200 plus citations, focusing on innovative fields such as bacterial concrete, self healing concrete, 3D printing, and AI applications in civil engineering. As a mentor and visionary, Dr. Rahul has delivered numerous expert talks and webinars, inspiring many students and professionals to pursue excellence. So, we are delighted to have such an eminent speaker gracing our occasion today. On behalf of the organizers, faculty, I extend a warm welcome to Dr. Chiranjeev Rahul Rolakanti, and we look forward to hearing his insightful address on the latest Constructions 5 BIM driven innovations for a sustainable environment. Thank you so much, sir. Over to you, Dr. Arnima ma'am.
Thank you, ma'am. Sir, we are delighted to have you here and look forward to your talk. Over to you, sir.
Thank you, ma'am. Thank you so much for your quick introduction, and thank you so much for this opportunity as well. Um, Good evening, everyone. Thank you so much for attending this session. Today, I'm going to discuss my research experiences on Construction 5.0, especially related to in the terms of BIM, driven innovations for a sustainable built environment. We are all very much aware of these advancements in civil engineering in terms of BIM, artificial intelligence, and IoT. And currently, the generation is also going into this digital transformation of civil engineering. So in this presentation, I would like to give a quick overview. What is Construction 5.0 and how does it impact the sustainability and resilience of construction field with some case studies around the globe and around the GCC countries and few from India. So within the time limited, I would like to cover few of them only because we cannot cover every aspect of BIM, especially happening around the globe. So let us try to take a walk on how it can assist faculty members to enforce the future generations. So here, in this session, I would like to discuss, and by the end of the session, participants will be able to understand the evolution from construction 1.0 to construction 5.0. So we will discuss what is construction 5.0 and how it is evaluated until construction 5.0, and how BIM acts as a digital backbone for innovation,
Video off
and
చేశాను.
especially in the terms
Unmute
of
themselves off
global,
చేశాను.
especially in the
Okay, ma'am.
terms of
అయిపోయింది ఈ చిన్న మొక్కలే కదా.
Arnima ma'am, can you please mute? So explain in the
ఇస్తాను,
terms of
ఎందుకంటే అది
global.
బొర్రెలు ఎలా కలిపినట్టు అనిపిస్తుంది. నిన్న మొన్న సత్యనారాయణ సార్ అన్నారు. ఉండండి.
Yeah, fine. So we will explore some global GCC and Indian case studies showing BIM driven sustainability. And we will try to have some idea on how the future research and academy industry collaboration opportunities in Construction 5.0 and this digital transformation can help us further in research and in terms of how we can educate our students later. So coming to this changing phase of construction, by the time like when we learn or when we are into the construction field, it was totally different. So nowadays, construction is no longer about concrete and steel, and it's all about data, intelligence, sustainability. So we have seen like we are fortunate enough that we have seen the construction without any technology right from starting stages, and we have seen this evaluation step by step, and we have seen generations how this construction technology has been evaluated and how this new technologies are integrated into this construction in terms of data, intelligence, and as well as now the major focus towards sustainability. So we all are aware that we have witnessed how the construction industry is undergoing a digital and cultural transformation as well. So we have seen so many FDPs or webinars, lectures, and construction people are also more focused into urbanization, climate change, and resource constraints, resource allocation, project management, and finding out for smarter solutions and as well as sustainable solutions. The changing phase of construction continues in such a way that now the next era includes this BIM, artificial intelligence, Internet of Things, robotics, digital twins. These are all now not futuristic. They are already being implemented in various parts of the world. And these integrations of technology is redefining how we can plan, design, build, and also operate construction projects. So that is why this session or this topic is emerging, where it is majorly focusing on human-centered technology, and it is integrated as a model focusing on collaboration between humans and machines to achieve sustainability. Here you can look into it, evaluation of the construction from 1.0 to 5.0. So how we are evaluating it. So construction by 1.0 is like focused on manual labor, craftsmanship, and there is no mechanization much. Then construction 2.0, now what is lacking in construction 1.0, they have addressed, and mechanization has been started, heavy equipment, construction plants came into the practice. Then coming to construction 3.0, so then it started industrialization, like prefabrication, mass construction, started integration of advanced construction methods, technologies in construction 3.0. Maybe we were in that era. So now construction 4.0, which is like after us, like past of digitalization, which includes BIM, IoT, and robotics and automation. So this BIM, IoT, robotics are already there, being practiced or implemented in construction 4.0. But now we are going further into construction 5.0. So which is like human machine collaboration. These are the major points in construction 5.0, that human plus machine collaboration. So focusing on sustainability, ethics, inclusivity, and resilience. So let us dig more into the construction 5.0. What is human-centric vision and what it is emphasizes on? It's a balance between technology and humanity. So technology should not overcome us, or we should not be affected by the technology. It's like integration between human-centric approach. So it's integration of digital tools with human expertise for better outcomes. In simple, construction 5.0 is like integration of digital tools with human-centric vision or human expertise for better outcomes. It is technology supporting us and enforcing us to come up with a better results. So coming to this focus on sustainable, safe, and inclusive built environment. So and it majorly encourages interdisciplinary collaboration. So until now, civil engineers and architects are only collaborating. So now, regarding this BIM, the software, IT people, and data scientists, so all are integrated now. It's an interdisciplinary collaboration where engineers, data scientists, architects, and environmentalists are also included, because in terms of sustainability. So this moves from automation to augmentation. So like machines enhancing human decisions. Like machines are not overcoming us. We cannot look in that way. So we can look in such a way that machines are enhancing our human decisions. Machines are supporting for better outcomes, giving some sustainable outcomes in construction projects. So I would like to say that like these are the key pillars of construction 5.0. So most of you are already aware of this. So let us see like what BIM. We are all aware, building information modeling. So which is a basic foundation. So BIM is not a particular software. It's a combination of softwares, and it's a process. It's a procedure. So where we include according to our requirements. So few of them are digital twins. So which is real-time replicas of physical assets. AI and machine learning, very famous, and which have predictive designs and which can mitigate risks. Robotics and automation, which will enhance safety, efficiency, and precision. Sustainability and green materials, which helps us for circular economy mindset and human-centric design, so which is inclusive and adaptable environments. So why BIM is the core of construction? So because there are so many other things which includes in construction 5.0. So as per the theme and as per the topics, we are limiting it to utilization of BIM or implementation of BIM in our construction projects. So it's not just a 3D modeling tool. We have so many 3D modeling tools, and it's a central data environment. Like when like organization is using BIM, it means that it has various branches, like so many tools are included, so many process methodologies are included. So all together, we are calling it as building information modeling, which will help us or which will enable us to take intelligent decisions. So some major aspects of this BIM can be enables collaboration between stakeholders. So it integrates design, cost, schedule, and sustainability. So in earlier days, we used to have Primavera or MS projects to see how this cost schedule is going on progress into the budget limit and resource allocation, and also now it's all improved, it has enhanced. It acts as a foundation for digital twins, which has energy modeling and facility management as well. So it connects to IoT and artificial intelligence system for real-time performance tracking. So this is why the BIM is the core of construction. So coming to BIM for sustainability. So how it can be beyond design. So how we can integrate BIM. So first of all is material optimization. So it's very important that optimization is the basic key of our project management techniques, where we need to properly plan, like we know all 5 M's, like machines, machinery, materials, manpower, money, management. All these 5 M's are all having a same goal of optimization. So it will help us for material optimization. So which will identify low carbon materials or low carbon construction methods using locally sourced materials, and it can also help us in life cycle assessment, like tracking embodied energy and carbon footprints. And this is a major point of sustainability aspect as well. And there are so many studies mentions that most of the waste coming from construction industry in terms of various forms. So construction waste reduction can be managed using this virtual class detection and lean scheduling. So we'll understand it's all like before the project itself, most of the projects are having a visual idea how it is going to happen, where it is going to happen, and they are also identifying uh, risk management, or can also identify like hazards. Coming to this facility management, so we are able to have a predictive maintenance for energy and efficient operations. There are so many examples now using 6D BIM related to energy data and 7D BIM, which is related to facility management. So this is one of the major aspects, like how this BIM can help us beyond design. So coming to this global sustainability imperative, so we all know this construction sector contributes 38% of global CO2 emissions. It might be more than this by this time. So BIM and digital twins can reduce waste up to 30%, so which is very huge. And we are working on so many research. The major part of the research is also to reduce the construction waste, or to have this eco-friendly materials and come up with different technologies or different methods, how we can control waste and how we can control energy as well. This is both leads to sustainability. So it also leads to, it also aligns with UN SDGs goal 9, which is industry, innovation, infrastructure, and which is goal 11, sustainable cities and communities. So we are majorly focusing this construction 5.0, which is leading to UN SDGs of goal 9 and goal 11. So majorly, this construction 5.0 aligns the civil engineering profession with global sustainability agenda. So we are all working on to sustainability agenda. Even here in Oman also, we have Oman Vision 2040. India also have Vision 2047. So all are focusing towards a sustainable, related to construction, we can say sustainable construction projects or sustainable constructions, sustainable methods. So this is a brief of what is construction 5.0 and how this BIM can be incorporated and what are the advantages. Because as it's a faculty development program, I'm not going to the basics like what are the advantages, disadvantages, how it can be used and all. So I would like to jump more into practical scenarios where let us try to explore some world BIM, how it is happening around the world with the driven sustainable projects, which has this implementation of construction 5.0, including basics like from principles to design to operations. So here are some examples. Excuse me. So I have gathered some projects. There might be so many projects, but I have taken like 3 or 4 examples of each, like global projects taken from UK, Singapore, and Australia. As I'm working here in Oman, so I have considered this GCC region, Saudi Arabia, UAE, and Qatar. Especially, I can say that Saudi Arabia is booming like anything. Like Saudi Arabia has lots of construction projects. They're coming up with huge innovations. Even in GCC countries, there are so many big 5 models and implementation of advanced construction technologies, especially like this BIM and all. So India is also having smart cities, metro projects, and digital infrastructures. So let us go one after one. So global case studies, BIM in action for construction 5.0. So it's Heathrow Terminal 5, which is London Airport in UK. So it has started pioneering digital integration. So it remains as a benchmark for large-scale BIM implementation, right from this design aspects, construction aspects, management, operations. So this project used BIM level 2, integrating design, construction, and operation data. Over 30,000 components were digitally modeled before physical construction. So this is very huge. So they're able to have a visual idea how these components were digitally modeled and how it's going to happen, like the appearance or what type of risks we might get in this while construction process. And also they have all gone through it. So they also identify this class detection and 4D scheduling. So it reduced their reworking situations, and it's by saving 40% and nearly 80 million pounds have been saved as per the studies. So the data model continues to support facility management and energy optimization. So it can says that early BM integration enhances life cycle sustainability and reduce waste. So these are some images of this Heathrow Airport, which is in London. You can also see this operations. So coming to Singapore's smart nation vision. So which is like citywide BIM and digital twins. So Singapore was among the first nations to legislate BIM adoption for all large projects. So earlier we were discussing about a particular project, but now we are discussing about a smart city. So Singapore is implementing a smart city technology. So like the Building and Construction Authority mandated BAM e-submission since 2015. So they are very ahead using this BAM technologies in their construction projects, and they are not implementing at project level. So they are implementing at uh, like the city level. Like they are able to provide a national level. So the virtual Singapore project created a digital twin of the entire nation. So you can see the image also, it's a digital twin of the entire nation, integrating real-time data on buildings, transport, and environment. So you can see like facilities having this energy analysis, flood prediction, and urban planning. So this all helps authorities to have an idea. So this is what like moving from building level BAM to city level BIM. So this is what the Singapore has done. So this is a digital twin model of a Singapore. These are the models that they have created. So coming to this Sydney Metro Australian in digital twin for operations, this project implemented BIM and IoT integration for real-time monitoring. So these are like all are digitally linked to maintenance schedules through 7D BIM. So like this is 5D, 6D, and 7D facility management. We have gone through this 7D BIM before, which is a facility management. So they are digitally linking all these maintenance schedules. And this helps to track energy consumption and carbon performance as well. So they have some predictive analysis and forecasted maintenance needs. So they have reduced the downtime by 30%. This is a very major problem where some clash in schedules or some issues in metro which delays a lot of trains and a lot of transport, suffering so many people. So this has driven digital twins which make public transport infrastructure smarter and greener. So this is an image of Sydney twins. So this is Sydney digital trains twin model. These are some illusionary images. So coming to this, what we can learn from this and how we can uh, utilize these case studies and what we can learn from this. So across this project, there are three themes emerges. You can see this government mandate, like policy and digital standards drive adoption and life cycle approach. So BIM continues to deliver value post construction and sustainability focus. So it is carbon, cost, and time savings are quantifiable. So from these case studies, what we have gone through this Singapore project or Sydney metro train and other project also we have gone through is Heathrow Airport. So all these are giving examples of, these have set an example already for how this government, like government mandates, like government has to take a lead. Government has to include these advanced technologies. It should support private organizations or construction organizations. So the life cycle approach and the major focus of sustainability. Then coming to case studies around GCC countries, so they are focused more on smart, sustainable, and vision driven. So they have visions, like they have 2040 visions. Other countries have different visions as well. So I can say that there is one project which is called as NEOM, which is in Saudi Arabia. So which is also called as the future of construction 5.0. So this NEOM represents the world's most ambitious construction ecosystem. So they have developed uh, using all the technologies which we were discussing. It's a fully BIM integrated design and the digital twins for city operations. So it's not only about designing, it's all about like designing, like from the basic to operations, even maintenance as well. So this NEOM has integrated BIM from designs and digital twins for city operations. And this line project has zero cars, zero streets, and 100% renewable energy. So that's why it's the future of construction. So achieving 100% renewable energy is like outstanding commitment for the future of the construction in terms of sustainability aspects as well. So they have incorporated AI, robotics, and modular construction. So which helps in reduce wastes and human errors as well. So you can see that focus on circular economy. So this is one of the key point which I have mentioned, that circular economy. So materials are tracked for reuse using blockchain. So that's why like it's interdisciplinary. It became interdisciplinary. This blockchain comes into the picture, and IT people comes into the picture. Data scientists comes into the process. All these enabling interdisciplinary actions. So it defines construction 5.0, like technology and human coexisting sustainably. So it's not only working technology, it's not only human. So as we discussed that the humans are getting support from the technology, like technology enhanced decisions. So this is a view of this NEOM project. You can see here, NEOM into the future. And the next example is like Expo City Dubai. So in the earlier days, it is called as Expo City Expo 2020 site. It's a place where it happens, but now it was transformed into Expo City Dubai. So which is a sustainable smart city, and it has a lot of scope for research. Like we can go into this topic where you can identify numerous technologies. So it was used for energy simulations and solar orientation optimization. It's not only using solar panels, it's also considered the solar orientation as well. So 123 LEED certified buildings with real time, like there are 123 buildings which are certified through LEED with real time IoT sensors tracking air quality and energy use as well. So coming to this, how this helped in reducing construction. So the 4D BAM helped in reducing construction schedules by 10%. Like the period, the duration has been decreased, and it has reduced waste by 45%, which is like incredible. Like almost 50% of the waste reduction has been done using this sustainability and BIM integration. So they have also used BIM along with Internet of Things, IoT, ensuring that sustainability is not just in design, so but throughout the operation. So it's a continuous process. So this is the overview of this Dubai Expo City. And coming to another part of the GCC, which is Qatar. So this has Lusail Smart City Qatar, and have got an opportunity to witness this. And even the construction architecture is also like mind blowing. The architecture, the type of colors they have used, the type of designs of the buildings, which has so many construction challenges, and it shows the wonders of construction. I can say that. So this Lusail in Qatar is the first smart city fully developed using BIM and GIS integration. Like now we are discussing about these projects or these technologies, and they are already ahead. Already they have implemented, and I think this is constructed a long ago. So BIM is used for all infrastructures and utilities. So in this project, they have used 60 BIM, which enable them for energy modeling, and asset performance simulations. And how it deals with, like, it has a central data hub which allows them for facility management using digital twins. Like as per the 70 BIM, the facility management is also one of the key aspect of this BIM. And these smart cities require BIM as their data nervous systems. So that is how the case studies from GCC countries have taken place. So just go around, like it is Neom, Saudi Arabia, and it is Expo City, Dubai, and Lusail Smart City in Qatar. We have more, but in coming to this Oman, so we are incorporating sustainability into construction projects, but comparatively, so they are very much into the tradition, culture, and their designs are more um, authentic, like they give most preference to the culture, but still they are implementing all these technologies nowadays, and it's ongoing now. Maybe like within, it's a major goal of Oman Vision 2040 as well. See, this was I saying, like the building designs, the building architecture. So it's like one Cornish area. It is like one special city. So which is the Qatar looks different. Like when we see the normal city, it looks so authentic and like GCC country area. But when you see the city, it's totally like very smart, huge sky towers, skyscrapers, and different technologies. Every building has its unique architecture. So what are the reflections? Like what are we going to take away from this? So the first major thing is which is vision driven approach. So countries have a vision, the governments had a vision, so they started linking it into national sustainability agendas, so which has supported construction organizations also to follow this approach. And the major problem here is in normal constructions or private construction projects, they generally don't risk because this require a lot of technology and skills are also required, and we generally have like I can say that simple words, it's like a starting trouble. Like we cannot directly implement something which is new. If we require some time, we have to see some good examples. If some good examples have been set, so then we try to follow them. So this is, it should be taken from, taken lead from this national level. So then it will slowly inculcate into construction projects. How the one more important aspect is that adoption, like they have adopted BIM, so they spent on learning it, mastering it. So then they started driven by public-private partnership. So only private projects cannot handle it, and maybe public government projects cannot handle it. So when this public-private partnership comes into the picture, so there are more scope that we can have this type of adoptions into construction projects. Then integration of artificial intelligence, IoT, and robotics for safety and efficiency. So these integrations of technologies are majorly focused on safety and increasing efficiency. And the emphasis is on training, capacity building. And this is what we were discussing, that we have to master it. So it takes a lot of time for, you can say like manpower. The manpower should be trained. We should have proper softwares. Like actually so many projects were happening here in, even in our students also they're doing projects. What are the challenges of implementing BIM? From so much of survey analysis and survey data, we have got feedback from industries that they're all aware. They all know that it is having huge impact. But very high level companies are ready to implement, but medium scale projects, they're not able to implement it due to so many challenges, especially having this lack of knowledge, uh, trained or skilled manpower. And this is where it is lagging. So it has to be considered that the capacity building is very important. Even the fresh graduates and the future engineers, they should have this in mind. Uh, they should learn from their college itself. So then they'll understand, because already settled people or senior engineers, so they're learning now, and they're in transition period. It takes some time. So then once the capacities of the individuals have been built properly, so then, and it also can be helped, like industry can come to academies, give some training, like maybe this session will also help some of you to understand how it is going around. It will help you to research, or you can take some examples from this, discuss in your classes and explore your research areas. So that's how it can take it further. So coming to Indian case studies, how this BIM is for sustainable development. Uh, I don't know, like any one of you have any idea about this Nagpur Metro Rail project? Have you heard about this India's first BIM implementation? Maybe we can have some interaction because I was continuously speaking for more than 30 minutes. So if it's fine, like we can have small interaction until now, what happened? So then we can continue further. Anyone have any questions or anything to share? Good to see that we have almost 200 participants. Like most of you might be having more awareness, especially in the areas, Indian regions.
So good evening, sir. Myself, Satya Prabha from Trichy, Tamil Nadu.
Yes, ma'am.
Sir, I have a question.
Yes,
This
ma'am.
BIM modeling, whether before starting the project we have to perform, or while execution we have to perform this BIM modeling, sir.
Before, ma'am, it's obviously it's before this implementation. So it starts from the basic principles. Whenever you have this idea of BIM, even this designs, planning, scheduling, all happens in the starting stages itself. So that's why if you take the example of Heathrow Airport, they have done this 40% of the project before they start itself, like visualization, the digital using this digital twin technology, they have fabricated everything and they're able to look into the aspects. Good question, ma'am.
Okay.
Yes, it has to be from
Okay,
the
sir.
basic
Sir,
principles.
another same way, another question, sir. For example,
Yes,
if it is a
ma'am.
government project, for example, if I'm a contractor and for example, I'm applying for a tender in a government project. But there will be some deviations based on the construction time, and because first the project should be getting sanctioned. Only after that I can start my work. So how
Correct,
BIM
ma'am.
modeling will help me for proper execution, sir?
Uh, yes, ma'am. Let me just go back. Like because we have taken the example here. See here, it will 4D BAM help us in reducing construction schedules by 10%. So when you are scheduling itself, it will have a clear idea. And I understand your question. You're talking about any amendments happens later. So that can
Yeah,
also
yeah.
be taken. That can also be taken care here. See here, which this 4D scheduling helped reduce rework by 40%. This is the major
Okay.
advantage and which has saved nearly 80 million. Ma'am, to be honest, like what you said in government projects, so if you have so many delays, there is a practical challenges.
Okay.
It works, ma'am. It has a scheduled reset because you don't need to rework again. So you just need to do some changes wherever these amendments are happening. So it will give you a fast result.
Okay, sir. Thank you so much, sir. Thank you so much, sir.
Thank you. Thank you. So any other questions, please? So I can also understand that what is lagging and how I can take it further. I can also focus on those points where you have some queries, or you can just share your experiences. Like, is there anyone who has already started working on BIM or any industry people we have who has an experience of BIM? Please share your experiences as well.
Rahul sir, we have the question and answer time at the end of the session. We can
Yes,
interact
sir.
at that time. Okay. Otherwise,
Okay.
there is an interruption to you, your flow of explanation.
Yes, sir. I understood, sir.
Okay.
Yes. Coming to this Indian case studies, how this BAM sustainable development. One of the best example is like Nagpur Metro Rail project, so which is the first 5D BAM implementation. So this is India's first fully 5D BAM managed metro project. So they have implemented 3D. Like you can see, when 3D is mostly related to design, and 4D is related to time, and 5D is related to cost. In the previous, we have discussed about 6D and 7D as well, which is facilities management. So this implementations of BIM reduced construction cost by 8% and time by 12%. This is the practical result of implementation of BIM, which has resulted in construction cost, because metro project might be a very huge project, and resulting in cost of 8% and time by 12% is a very huge margin, and especially time, because we are facing so many issues in construction delays, and that can also be addressed. So Nagpur Metro Rail project has this BAM dashboards which help to monitor material usage and CO2 emissions, and this enhances transparency and sustainability in public infrastructure. So these are the best example of implementation of BAM in India. So this is view of this 5D implementation, which is Nagpur Metro Rail project, called as Metro Rail project. So coming to this Amaravati Smart City, like I can see the disclaimer. Coming into the practical realities, we can talk about that how they have started it and how they have designed it. So coming to this implementation of digital twin urban planning, the capital city project in Andhra Pradesh planned entirely with BIM and GIS integration. So which has an advantage of simulating energy efficiency, and it also has importance of the water flow, where conservation of water and environmental comfort. So it has been designed as a zero carbon city. So using this BIM-led energy models, we might have heard that news that people from Singapore has come and helped us in designing this project, because they are already ahead. That if you see the example of Singapore city, which they started in 2015 itself. This BIM facilitates evidence-based decision making in urban planning. So this is one of the major part that urban planning has huge impact. And coming to this, it's not only the government initiative, it's not only related to construction organizations. So we have some set examples by corporate leadership also. So they are also integrating this BIM in their construction, because Infosys is a very well-established organization which has huge constructions around the country, even around the world, some places. So this uses BIM to monitor energy efficiency, lighting and water recycling across its campuses, and this leads to sustainability. So each building model for passive solar design and renewable integration. So it has achieved 40% energy saving. So this has a huge impact. 40% of energy has been saved, and it reduced operational costs. So this is a major takeaway from this Infosys project. Like BAM driven sustainability is as relevant in private sectors campuses as in public infrastructure. So we have seen one example of public infrastructure. So we have seen one example of this private this one. So what not, like Vizag is also not less to consider it as an example for a smart city mission. So we are all very proud to have this Vizag smart city. So over 100 smart city projects can leverage BIM for urban analytics, and current pilot projects in India. Some examples are Pune, Surat, and also Visakhapatnam integrated this BIM GIS for waste and water management. Maybe at the end in QA question and answers discussion, I would like to know from your practical experiences how much practical it is being implemented, and what is the improvements of Vizag in terms of smart city. So BIM helps visualize sustainability and resilience at city scale as well. So one public project and one private project. Nation, we have seen the example of Singapore. At cities, we have examples of Pune, Surat, and live example of Visakhapatnam. So now, I have completed some examples of the case studies. So now we are diving into what is the advantage of this session, or how we can look into these aspects, and as an academic faculty, so how we can collaborate, especially in terms of Indian context. So nowadays, your 3D printing buildings all are already being implemented. So next, IITs and NITs now developing their construction 5.0 labs, collaboration between academia and government for BIM. So this is most important. The research should help government to take some decisions related to this integrations and sustainable construction training. So this is very, very important. Like training is the major key role. And as a faculty, we have to update ourselves and we have to reinforce the future students, future generations with this knowledge. So they'll select this as one of their career options as well. So academic capacity building ensures that India's next generation of engineers lead the construction 5.0 movement. So it is in our hands as well that how best we can contribute to the country and how best we can contribute to the development of future generations in enhancement of this BAM or construction 5.0 implementations. So coming to this BAM driven innovations in construction 5.0. So after the case studies, we are getting into this major theme of this session, how this BAM driven innovations in construction. So you can see digital twins and predictive maintenance. So again, if I start speaking about digital twins, it's a huge topic again. So in simple, it connects BIM models with live sensor data. So if for quick understanding, so digital twins connect BIM models with live sensor data. So how it happens, like the real-time energy, occupancy, maintenance insight. So then coming to this predictive AI models detect faults before they occur. So this is the major part, like avoiding construction accidents, construction delays, and it helps majorly in risk management. So predictive AI models detect faults before they occur. So this will help us. This is the reason for reducing rework, saving time as well in terms of saving money as well. So the one of the best example which I have taken is like Dubai municipality uses digital twins for storm water systems monitoring, because obviously we have less rains here, but whenever we have rain, so they are trying to monitor that because it will leads to floods and it leads to a lot of operational disturbances. So how this AI and machine learning in construction can be incorporated? So like as we already discussed, BIM is not a particular tool, so it has so many collaborations. So when you collaborate this artificial intelligence with BIM, so it has a generative design. The first part is like generative design, like which has multiple sustainable design options and which has a risk prediction. So the same we have discussed earlier, it predict the risk, which will help us to analyze the site data for safety compliance. So when we avoid accidents, when we have safety protocols, it has a huge impact, and material optimization as well, like choosing low carbon alternatives and which material fits in which component of the project. So there is an example that Autodesk Project Refinery uses AI for energy efficient design solutions. Now I think we are all aware of this AutoCAD AI as well. Coming to robotics and automation. So how this will help, how this will drive this construction 5.0. So construction robots now perform repetitive and dangerous tasks like 3D printing structures. This is one of the best examples which is seen in Dubai's 3D printed office, and we have drones for surveying, and we have drones nowadays we are using in construction project for maintenance, surveillance, inspections, maybe especially in places where we cannot easily move around. So drones can help us, especially in terms of health and safety. Also nowadays they're using this drones inspection, identifying who is maintaining health and safety or who is disobeying safety principles, and BM verification. So robots for rebar tying, bricklaying, and concrete finishing, and we have seen so many robot machines which are already doing so many construction aspects as well. This robotics improve safety, speed, as well as sustainability. Yes, I do agree there might be impact on human jobs or human involvement in construction in terms of laborers, project managers, and all. So there is a challenge. The green materials and BIM integration. So BIM support decision making for green materials. As we were discussing about alternative materials or low carbon efficient materials, this is one of the example, like databases like embodied carbon in construction calculators. So it will help us to understand how much, if you use the material, what is the, what are the CO2 emissions, carbon emissions, which materials can help us in reducing it, so which will help us to design a sustainable project. So which has a life cycle analysis, which is directly linked to BIM objects. So example, we have we have certified projects integrate BIM to calculate embodied carbon. So as we discussed, it's interdisciplinary. So blockchain technologies comes into the picture, and which will help us for the transparency. So this blockchain adds trust and traceability to BIM processes, like which ensures data integrity across stakeholders and tracks sustainable material resourcing. So as we have discussed earlier, the pilot use of NEOM for verifying recycled steel and concrete provenance has helped this integration of blockchain and BIM for transparency. So I have a flow chart, I'll show it later. So integration of IoT with BIM. So it's like IoT is all about like sensors, communication, signaling or alerting. So which monitors temperature, humidity and occupancy. The sensors directly connected to BIM, so which will enable dynamic energy adjustments. Again, Expo City Dubai uses 2,000 plus IoT devices linked to its BIM for real-time energy optimization. I have seen the Dubai Expo, not only for this climatic or weathering actions, it has a lot of real-time energy optimization as well. So this is one of the flowcharts which I have identified, which has a lot of meaning. So how this future trends, IoT-driven predictive maintenance happens. So artificial intelligence and machine learning, digital twins, blockchain, 5G connectivity, augmented reality and virtual reality. So all this together helps promoting this BIM driven. So coming to this academia, research and industry integration. So how we can incorporate this into our research? So many of you might have already started doing research into it and gone through these different courses are available. And faculty play a pivotal role in bridging digital theory and real world practice, because it starts from here. So when you create some interest in your students, when you explore, like when you expose them to this technologies, so they started that interest in them, and they might do some courses though before they graduate. If they are able to inculcate some of these technologies, so they have better option for employment as well. So it will increase their employability skills, and this is one of the major skills gap. We call it a skills gap, which is identified from the graduates. So to make them industry ready, so we have to develop this interdisciplinary courses. I think nowadays, I can see we have started some courses as well, especially in computer science branches. They have started this artificial intelligence and all. So I have seen some courses around BIM in civil engineering, AI in civil engineering. So maybe some of you can enlighten me. So are they really implementing? Did we start any courses, especially focusing into this interdisciplinary areas, encouraging industry collaborations for live student projects? So nowadays we are doing so many projects of students, especially bachelors and masters as well. So bachelor projects and master projects as well. So this will help them to have an idea before they get into the industry. So promote research on construction 5.0 technologies as well. So coming to the skills and competencies of future engineers, which we are talking, the future ready graduates should possess. They should have basic idea. At least they should have some, not total hands-on experience, but they should be aware of this. What is BIM modeling and how does it help us? Maybe organizing some training, or maybe like 1 week training programs or pre-graduation training programs can help us in incorporating this or knowledge into the students of BIM modeling and data management proficiency. Maybe in colleges can also come up with some interdisciplinary projects at graduation level or at least at master's level. So two students from different branches can coordinate and they can start doing their project, coming up with different outputs. understanding of the sustainability assessment tools, and especially it's very important for the future generations to be familiar with artificial intelligence, IoT, and digital twin workflows. Yes, Gen Z is already much aware of these technologies, but in terms of construction, how this can help them in future, integrating these technologies into their education or into their development, getting industry ready. So there are so many options like BM in civil engineering, roads, bridges, and more. Like there is there are so many options where uh, this BM can be incorporated into civil engineering. So coming to this conclusion part of this presentation, so I have not limited to, but I have listed some research themes for faculty. So where you can emphasis on digital twin development for heritage conservation, AI-based construction waste reduction models, BIM GIS integration for flood resilience, especially it will help most of the monsoon regions in India. So blockchain enabled material tracking in sustainable supply chains. So this will also help us in interdisciplinary. Maybe at faculty level, there might be better opportunities for these collaborations in terms of research. So it is also recommended that industry should also collaborate with academicians. I think L&T has uh, some implemented plans already, collaborating with the IIT Chennai or the IIT Delhi. I'm not sure with the organization, but I have read some articles related to this collaboration. One of the part is like 3D printing in IIT Chennai. So joint labs with construction firms and software providers, faculty industry internships. This is very important. So not only, so we have a model which is called as MEC Bridge. So not only students are attending internship, so they are sending faculty for also for internship during a summer vacation. So they have sent a faculty to industry for 1 week internship. The faculty has traveled along with the industry people for this 1 week, which enhanced the vision, like how we are teaching and what is required. So which is reducing the gap between industry and academia. So this is a this is a good idea, which I felt like faculty industry internships on BIM implementation. So if organizations can have some plans on this, it will help really that faculty can come back and delivers sessions to other faculty members as well as for students, which will incorporate or inculcate this knowledge into all academicians. So collaborative consultancy on sustainable design projects. So yes, this is a major part, and now we are all talking about this can happen or this is the future and all, but there are so many challenges. So where we need to focus on while implementing or integrating these into construction projects. Let us have some few look. So challenges in adopting construction 5.0. So lack of skilled professionals, high initial software and training costs. This is a very, very major challenge from our surveys and from our projects also. We have also identified that the initial cost is very high. And the training of the faculty is, training of the industry people or training of manpower is also very difficult because they have to invest specially on this. So they are not getting any any returns in economic aspects, but it will show in their future projects. Interoperability between BIM platforms, like it's a combination of different softwares. So we are not, if we are well versed with one platform, it's not sufficient. Like we have to improve our expertise in various platforms and resistance to digital transformation. Without any offending statements, like there is so much of resistance to digital transformation. And when we are habituated to one type of teaching or one type of learning, and even the construction industries are practicing one particular form of conventional construction methods, it takes time for us. And not everyone is ready to kickstart this digital transformation. So we have a lot of resistance from ourselves, from organization perspective, and from government perspective in terms of profit ratios, in terms of this estimations and tenders. So we have to restrict to the budget. So we have so many resistances and challenges. and how we can overcome this. So maybe I have already explained you some ideas already. So it has from the Singapore model. So the national BAM policies and mandates. So it has to start at that umbrella level, like the top nation has to bring up some these policies and mandates, give some feasibilities or give some incentives for companies who are ready to work on this BAMs, cross-disciplinary curriculum integration. So we were also talking about this developing new programs or developing new specializations where artificial and machine learning in civil engineering. I'm sure that it is already there. I have seen some branches already have already started. Incentives for green certification and digital adoption. So government has to make mandatory that lead rating or breed rating. So these type of ratings should be made mandatory or give some incentives or tax reductions, whatever incentives the government can provide. Faculty as knowledge ambassadors for construction 5.0. So hopefully from this session, you might have got at least few points. So you are the ambassadors now, which you can take it further into your research, further into your classes, to your students, empower them, enlighten them towards their wonderful careers. So this is a brief overview of the next decade, how it is going to be. And as per the global trends, it is like going to be carbon neutral construction as standard. So nowadays we have a lot of complaints that construction industry creates a lot of pollution. It is one of the major part, like I'm not sure with the percentage, but it's around like 20 to 30%. The construction industry is creating various types of pollutions or harmful to sustainability aspects. So rise of autonomous construction sites, city scale digital twins. These are all going to happen in future, expecting in the next decade. So human machine, so this is construction 5.0, human machine collaboration models in civil engineering. So the way forward, so how we are looking into it, and as participants in from this session or as a country or as a global perspective, let us stick to this Indian region. So how Indian academia align with global construction practices. So this is a major challenge, and if we are able to take it further, so whatever the challenges we are discussing can be minimized. So what digital skills sets are missing in civil engineering education? So incorporating this digital transformation. So first, the faculty has to enhance themselves, equip skills, gain knowledge, so then we transfer to students, the future generation. And how can BIM be integrated with sustainability courses effectively? So this is a suggestion for the way forward. So I hope and I expect the major key takeaways are, you might have understood what is construction 5.0, which is a human-centric evaluation of the technology. And BIM is the foundation for sustainable data-driven construction. And collaboration between academia and industry is essential. Maybe you start developing industry connections and get into industry, get some trainings, even faculty as well as students. Sustainability and digitalization must coexist for future-ready infrastructure. So I would like to end in such a way that technology alone does not create sustainability, or not even humans cannot create sustainability. It's all about integration, and our decisions do. So construction 5.0 reminds us that the future of civil engineering lies in combining innovation, empathy, and environmental responsibility. Thank you so much. That's it from my side. I hope I stick to the time as well.
Thank you, sir. Thank you, sir, for your futuristic and engaging session. Your insights into BIM and sustainability will truly enlighten. Shall we proceed to the interactive question and answer session, sir?
Yes, ma'am. Yes, ma'am.
Participants who wish or ask any questions can unmute themselves, or you can post any queries in the chat box.
You can share your experiences as well, which you have through this BIM. And I have also pointed some points in this during the discussion that some already specialized courses are all in progress.
Sir, one question for you, sir.
Any code, yes, ma'am.
Is it any code relating to BIM?
BIM is not a particular item, a particular method. It's like an integration of various aspects. Like maybe the question is from Chandrasekhar.
Chandrasekhar.
Sir. Chandrasekhar sir, to my knowledge, I have not gone through any codes of especially related to BAM because BAM is not a single process. Like it can correlate. Like there are 5, 6 combination softwares. Like where how you use it together. Like it's a combination of different technologies. To my knowledge, I have no ideas. I have never gone through any code of BIM.
One more question, sir. What is the
please?
cost increase or decrease due to BIM inclusion in the projects?
Yes. So when you include BAM into the projects, initially the cost will be high because you have to get the license of so many softwares and you have to get trained as well. That's what we were talking. This is a major challenge that skill development related to BIM. But when you start implementing the project, so you have witnessed some savings like reduction of wastage by 40% or saving in the cost project by 40% or 80 million in Heathrow Airport. So these are all the examples of how this cost can be reduced. There are proven evidences that BIM helps in reduction of cost, reduction of time, as well as enhancing safety throughout. So there will be cost decrease in all together, like balancing the initial and operational aspects.
One more question, sir.
Thanks for the clarity. Sir has given ISO 19. Thank you, sir.
Yes,
I am also not aware of this Indian codes.
One more question, sir. Where can I study BIM? Are there any government organization to offer certification? How do I approach getting BIM certification?
Dr. Swaminathan, sir, practically, I'm not aware of this government organization certification, but I have gone through various private organizations where they are providing these BAM certifications and certifications. They will teach you so many courses. There are so many BIM institutes as well, but government organization providing or offering certificates. Sorry, sir, I'm not aware of that. Okay.
One more question,
Yes,
sir.
yes, ma'am. I'm able to read the questions. I'll try. If I'm missing something, you can help me out.
Okay, sir.
BIM is actually used in transportation and road construction. Coming to this transportation, which is an operational aspect like smart cities, the smart cities and even the metro projects, which I have given examples of Sydney metro project and even Nagpur metro project has clear evidence that BIM is actually used, which helped out and they have implemented in transportation. And coming to road construction, not only road construction, any type of constructions, we can implement BIM. Naidu sir, yes sir, digital twins in civil engineering is all about like you create this like we were discussing that how we can develop this digital twin is like it's an development of the models. This can be the examples which connects this BIM models with live sensor data. Like you are creating it as I have shown the example of Singapore that they have created the digital twin model, which has this real-time energy occupancy. It has this AI integration will default faults like it can predict. So this digital twins for stormwater monitoring Dubai municipality. This question has a lot of explanation required. So again, I have to start a specific session related to digital twins, and maybe I can take it further, like in coming future, if I'm given an opportunity for any sessions, I'll take it as my next delivery of the digital twins in civil engineering, focusing on particular aspect. Thank you, Chandrasekhar sir. Anyone would like to give any feedback or anything where we can improve or what else you are expecting maybe? I'm not sure whether I have reached your expectations or not. If you can give me feedback, so it can be my take forward where I can focus in future sessions.
Participants are requested to unmute their and can give their feedback.
Yeah, the session is very informative, sir, Rahul. And it is the up-to-date 5O is the latest construction what the globe is following. But
Correct.
it has to become to India. I think it is introducing from
Correct.
4.4 to 5. It is going now.
Correct, sir.
Yeah, faculties. I think it is you updated. You enlightened the faculty first, so that
Yes, sir, exactly. That is a
yeah.
major theme of this session as well, because we are not into the industry, but we are. My intention also to just bring this information, global information, to the faculty level. So now it started from their minds, and some can start with their research, some can start uh, motivating their students. So, however, we are increasing our network and increasing our team. Very nice topic, sir. I really appreciate your team for organizing such sessions and selecting very emerging topics.
Yeah, in academics, I think already in the syllabi, I think artificial intelligence and machine learning is introduced to our BTech students, and
That's fantastic.
also data science. It is all introducing. I think our students are learning these
It's a
interdisciplinary subjects.
very good to listen, sir, because you are already ahead of us. Like you are already incorporating them into your academics and started specific programs as well, which is highly appreciable.
Good evening, sir.
Exactly, Chandrasekhar, sir. Yes, ma'am.
Sir, what I felt is that the session is good and extremely out of the box. So, what I felt simply is that if I have shown any of the basic image with the BM designing, it could have been more excellent. What I thought. Because
Correct,
this is my
ma'am.
third session on this BM and sustainability topic. Both the two sessions are from IIT Chennai only. So what I
Okay.
felt is that if I have seen that type of hands-on, at least what you are showing, it could be more excellent. I thought it.
Good. Like
Yeah.
in the previous two sessions, did you find any practical
Yeah,
approaches
sir.
of
Yeah,
explanation?
sir. Somewhat. Yeah. Even I have
Yeah,
note down also.
yeah, that's
Yeah.
good because to be honest, like we are not exposed to that BIM integrations in it because we are into academics, right? So I
Yeah.
have not participated in any BIM
But
integration.
now, but now the curriculum is based on this implementing BM lab to the
Okay.
graduate students, right?
This is a nice takeaway for
Yeah.
me as well because next time I will also go for one internship training for BIM integration so then I can come
Sure.
back with a practical example. As of now,
Yeah.
I have no practical example where I have not worked on.
Even the session is too good, sir. Thank you. Thank you so much.
Thank you. Thank you so much for your genuine feedback. I really
Yeah.
appreciate it,
Thank
which
you.
helps me to grow as well. Thank you.
Thank you, sir.
Gautam, sir, I have no idea, sir, which private organizations, and I cannot mention them as well because it depends on like you might do some research because I know that I don't know, like, this is not a correct platform to recommend some companies who are doing certificate courses because I don't want to take this credibility of them or sorry about that. Because it
Sir,
should
good
be
evening, sir.
approved when we are talking about a particular course, it should be approved by your colleges and all. I'm not sure about that.
Sir, good evening, sir.
Yes, sir.
Sir, Giridhar here.
Hi, yes, sir. Yes, Dr. Girdhar, yes.
Yeah, thank you, sir. Sir, there are so many research scholars also here. So can
Uh,
you give any suggestions to them that the opportunities globally or after completion of their research work, after
Exactly. So there
awarded?
are so many opportunities now. Like these are the research themes which you can see on the screen. I think I'm not sharing the screen, right? Sorry. Uh,
Yes, already. I mean, it's
It's
visible.
already full. Okay, fine, fine. So you can see this digital twin development, especially you can consider this heritage conservation. So we are all running behind the technology, concrete jungles, and also the one sensitive area is that heritage conservation. So implementing these technologies without losing the heritage, like especially in Oman, they are very much focused and they are very much conserved about their culture, their heritage. So whatever the development happens, it should not affect their culture, their heritage. So the countries, especially focusing on this, this is one of the important research area, and we all are already working on construction waste reduction models. But how you can use artificial intelligence? BAM JS might be a bit older version, so blockchain could be one of the taking like interdisciplinary. Maybe you can come up with a computer science faculty or sometimes management faculties as well, like how they are incorporating them and how we can bring into civil engineering. Electronics engineering, electronics and communication engineering and computer science engineering, they are our best peers where we can start working collaboratively. And if you can publish some good papers, there are huge scope for research grants. Even ourselves, we have the research TRC, the research council in Oman. So providing huge funds if you are coming up with this type of construction 5.0 or BIM or artificial intelligence. So grants can be the next target. And even government can also provide. International grants are also available in these things.
Okay, sir. Thank you.
Any questions from the participants?
Hello.
Yes, ma'am.
Yes, I agree.
Yeah, ma'am. Shall we conclude, sir?
Okay, ma'am. Please.
Thank you, sir. Thank you for sharing your expertise and valuable insights with us. Your session has been truly enriching and inspiring. On behalf of the organizing team and all the participants, we extend our sincere gratitude for your wonderful presentation. With this, we conclude the first session of our AICTE ATAL Faculty Development Program on sustainable practices and innovative trends in civil engineering.
Thank you so much, ma'am.
Thank you, sir.
Thank you once again for the wonderful opportunity.
Thank you, sir. Thank you very much. Sir, with your permission, can I share your details to the participants or someone asks about
Yes,
their
sir. Yes,
doubt?
sir. Please, please. Like you can share my LinkedIn profile as well. Like if you wish, like I can also share my LinkedIn profile as my
Sure,
contacts
sir.
and like. I also shared my LinkedIn profile, so it will also help for improving more connections.
Yes, sir. Thank you. Thank you very much.
Okay, sir. Thank you so much, Dr. Giridhar. So can I leave the session?
Yes, sir. Yes, sir. Thank you, sir.
Thank you. Thank you. Thanks, sir.
Our resource person for the second session has joined. Welcome to the session 2 of the day 3. Welcome to the session 2 of the day 3 of AICTE ATAL Faculty Development Program on sustainable practices and innovative trends in civil engineering. Our next session is by Dr. B. Santosh Kumar, Deputy Executive Engineer, Water Resources Department, Vijayanagaram, who will discuss on harnessing wind and water, eco-friendly engineering practices in civil engineering. Before we begin, I now invite our faculty colleague, Dr. G. Giridhar, Associate Professor, to formally introduce our eminent speaker to the audience. Over to you, sir.
Thank you, Arnima madam. Thank you very much. Good evening to everyone participant. Good evening to each and everyone present here. It gives me immense pleasure to introduce today's distinguished speaker, Dr. B. Santosh Kumar Garu, a dynamic professional and accomplished academician in the field of civil engineering. Dr. Santosh Kumar Garu is currently serving as a deputy executive engineer in the Andhra Pradesh Water Resource Development, where he has been contributing. Am I audible, ma'am?
Audible, sir.
You are audible, sir.
Okay, thank you very much. Where he has been contributing his expertise for over 2 decades in the design, investigation, execution, and maintenance of major irrigation projects, including canal systems, earth dams, hydrological investigations, and CM and CD works. Academically, Dr. Santosh Kumar Garu holds a PhD from Geetham University, Visakhapatnam, and master's degree in structural engineering from JNTU Anantapur, and further diversified his academic pursuits with a Master of Science in Psychology and a Master of Arts in Philosophy. His multidisciplinary background reflects his passion for both engineering precision and human insight. He is a life member of several prestigious professional bodies, including the Institute of Engineers, India, the Indian Geotechnical Society, and the Indian Institute of Bridge Engineers. Dr. Santosh Kumar Sir's research interests include seismic design, dynamic analysis, transmission lines, and reinforced concrete structures, with a notable doctoral thesis on the K4 factor in low-rise and dynamically sensitive structures. He has published and presented multiple research papers, holds 3 Indian patents, and authorized a textbook on remote sensing with 78 citations, and several invited talks and keynote addresses to his credit. Dr. Santosh Kumar is a passionate researcher and a motivating mentor. Beyond his professional and research accomplishments, Dr. Santosh Kumar has shown keen interest in emerging technologies like Python, artificial intelligence, IoT, and machine learning, which enrich his technical and analytical capabilities. We are truly honored to have such a versatile and inspiring personality with us today. Please join me in warmly welcoming Dr. B. Santosh Kumar Garu to deliver his session and share his valuable insights with us. Sir, we are heartfully welcoming you, sir. Thank you. Thank you very much. Over to Santosh, sir.
Thank you, sir, for nice introduction to me. I am B. Santosh Kumar, working as a deputy executive engineer. Yes, my screen is visible, sir.
Yes, sir.
Yes. This is B. Santosh Kumar, working as a deputy executive engineer in the irrigation department of Andhra Pradesh. My PhD is in the wind engineering, and I am professionally in the irrigation department. Both are the fluids. The fluids are the both non-compressible fluids, that is the wind and the water. So first of all, we are firstly wind engineering is the main topic. We have to be discussed in the ALCTE, and that one the second one is the what is the rubber dam and other recreational, and what is the actually from the 20 years back what the irrigation department has adopted the renewable energy. Still it is the working without any hindrance to the department. That is to be delivered to from my. First of all, the first topic is, before we entering into the wind, we are in the earth, and earth is with the pressure variation with reference to the height. The height is with the troposphere, stratosphere, mesosphere, and thermosphere. It is the geography up to the troposphere. The whole pressure variations, temperature variations, and the velocity variations are there. Beyond the troposphere, that is the stratosphere, where there is the ozone layer, and above the stratosphere, there mesosphere and thermosphere. These are the only for the meteorological department. Our wind engineering is considering over the troposphere, where the wind is the more oscillations when we are getting to the more turbulence in this region. And the whole troposphere, the variations of the weather climate is undergone to the many changes. That is why we are considering it to the up to the 15 kilometers. That is the 5 to 15 kilometers. 5 kilometers to 15 kilometers. That is the 5,000 meters to 15,000 meters is the only the atmospheric boundary layer. Beyond that, there is the only the thermosphere and mesospheres only. So before that, when we are encountering the any code, any life, we are the two aspects. One is the future, second one is the past. The past is the history. Without history, we have no science, and we have the no research. The research advances are from the previous, where there is the failures or the sustainability. Before this is the before Christ, the towers of Babylon, Iraq 561 is the first tower in the history. It was taken from the internet also. And in India, it is the Ranganath Swami temple of the 80-meter site. These are the ancient structures, tower structures. These are the wind enabled structures. These structures have been constructed from the ancient historians in the all over the world. That is done at the same time. The base is the pyramidal shape. The pyramidal shape of the gold, not only for the pyramids, the pyramidal shape is the 120 degrees of the 120 degrees of 120 degrees. It is the 360 degrees. That is why we have to the stable structures. They have constructed the large bases, either it is the circular, either it is the rectangular, or any type. But the foundation is the bases. The foundation is the major structure of the formation of the pyramidal structure. So there is the tall structures. The wind is the mainly have the resultant of the tall structures, steel lattice structures with rivets and bolts and weldings, steel force. These are the structures which are the constructed with the wind loads have to be taken into the consideration. These are the only flexible structures, not a rigid structures. Even rigid structures also we are taking into the consideration of the wind, but the inertia was having the higher effect, so that the wind effects is very, very less. But these tall structures, where there is the highest porosity or the highest flexibility, these have to be considered for the wind load structure, wind load on the structures. So that is in case of the before the working stress method and the limit state method, ultimate load method. The France, that is the E-Fields tower. The E-Fields means that is the cantilever action when compared to the column action. The cantilever action is in the working stress method. We have shown that when there is the wind stress is 1.33, 33 and 1/3% is greater, up to the 1/3 percentage, it is taken as it is the wind structures. It has to be increase the wind structures. In case of you have to provide in the column structures. Column is the vertical load, but when the wind is horizontal, when the vertical load is coming, and with the horizontal load, the wind load has been coming, that both the wind load and the vertical load and horizontal load up to the 33%. There is no necessity of any necessity extra safety, but up to that only we have to consider that the cantilever structures and the column structures. That is why we in the previous working stress method we have taken it the 33%, increase the 33% for the wind loads and 25% for the rivets. But in the limit state as well, already the philosophy is taken into the consideration of probabilistic design, that was evaded. But it is the column. Column means also the G means gravity, N is the wind loads. Total wind loads and gravity loads divided by gravity loads should be less than or equal to 1.33, less than or equal to gravity. This is the 4/3. This is the column structure. That is the cantilever structures. That is the working stress method, and the second one is the limit state method. The second one, this is the E-Fields tower. The E-Fields is the one type of the formation of the wind structures. That is the ground formation. That is the plan formation. Second one is the Washington Mountain. Same. It is 1884 to 1889. This is the column structures. The base width is very, very less, and it is the only the creating the loads on the only the column structures. But it is the 169 meters. But it is the cantilever structures. It is the 300 meters of Eiffel Towers. That is why it is the Eiffel Tower is the broad width and prismoidal. This is the column with the column. The base is very less. This is the Washington Mountain, 1840 to 1815. Column structure. It is the 169 meters of the height. So from the 1960 to 2011, there are the so much of the height of the structures, skyscrapers, 634 meters to 329 meters have been constructed. As the research is going on, different methodologies, different materials have been put into the construction, so that there is a recent research have been pronounced for the wind engineering, recently adapted from the wind engineering from the last decade or the last 50 years. These has been increased from the 0 level to the 1000 meters level, sir. That is 1 kilometer height of the structures. Better one story is the 3 meters height, but there is the 300 into the 300 into 3 that is the 3300 stories. These are the so much of structures have been constructed. For these structures are the only the loads are considered as the wind loads. This is dominant load is the wind load. So kindly see it. When there is in the classroom, in the 360, 380 meters and 820 meters are the diagrams are the same in the classroom. But it in the 1930, that Empire State was the constructed as the 380 meters. In the even the Burj Khalifa, it is the 828 meters. That is why we have shown that figure set is that type of the height and that type of the scaling is provided in. That has to perceive the what is the height of the structure when there is the 1930, what is the height of the structures when there is the in the present era. There is the 500 meters is top. There is 380 meters and 830 meters, at least 500 meters higher than the 1930 to 2025. So in the history, there are so many wind failures have been observed, and we are taken from this books and the internet. There is the first in 1836, the Brighton chain pier bridge failure was first in engineering failure was observed in the history, and that it is similarly the Tay bridge failures was the shown in the wind failures. These are the only wind failures in the ancient history. That is the even in 1836 and 1879. This is the famous Tacoma Bridge. This is the fluttering, 1945. It is the one of the fluttering. This is the waking of the wind waking, and it was the collapse due to the waking of the structures in the 1945. So this is the interference effect. Interference effect means the interference effect and one these are the silos and these are the thermal engineering structures. These large structures, these are collapsed due to the interference effect. That is the from front end to the rear end. There is the highest wake. Wake have been formed. These are collapsed due to the resonance effect and the interference effect. That is why we have to in the 1965. These are collapsed. So why we have to learn all these things before that going into the unique code or the unique prescription or any doctor? The doctor has asked ours to what is your why you are coming to the what is your problem, why you are coming to the same that is the doctor has asked our history. Before we going into the our 1870 and 80 our 875 code, we have to come across the past past failures. Thus, past values is the future sustainability. That is why we are putting all these things as our in this lecture. So in this India, the broad design of aspects is there is the two types of the broad design aspects in the force-based design and the displacement-based design. The wind load is the force-based design. Even though dead load, live load, snow load, blast loads are force-based design, but in the displacement, exactly there is the earthquake load. This is the displacement. This is the inertia, and the earthquake load is acting on the bottom of that is the foundation of the structure, and the wind load as acting on the total of the structures from the base to the top. That That is this is the force based, like dead load and live load, wind load. In this is the displacement based, is the earthquake load. These are the so different. The design philosophy is different from the one to other. That is why we are taking into the wind load as the force based designs. Oh. So atmospheric boundary layer means the atmosphere up to which the thermal equilibrium have to be taken into the consideration. The wind force up to the where. 1 minute. The wind force have been taken into the consideration. In this atmospheric boundary layer, the variations of the wind and in case of the mean wind forces, waves or turbulences. Mean wind forces means it is the slowly varying. The turbulence means the very small time, that is 1 second or the 0.5 seconds or half seconds. It is the highest variations. This is the diagram where the mean wind force is varying in the slowly varying in the large time, and the turbulence is the highest variations in the smallest time. That is the 2 seconds to 1 second, minus 2 seconds to minus 2 k seconds. The waves are the somewhat between the mean wind speeds to the turbulences. The turbulence is the direction, the wind profile. The wind profile has been provided, has been defined as the horizontal direction of the wind profile, that it is provided from the 0 to highest, that is the highest wind force at the highest of the atmospheric boundary layer. That is the gradient wind speed. So the wind has to be measured with the anemometer. This is the anemometer where it has the cup anemometer. It has to be rotating, and the rotating pulse have been given to the. This is the anemometer from the 1 hour to 1 hour. This is the 3 hours to 3 hours. These are the peaks. These are the single peaks. These are the only 1 second peaks. This is the actual, this anemometer diagram taken from the Hudud cyclone, where it is the 180, 120. This is nautical miles, 184 kmph. That is the single peak. But India has to taken the 3 seconds of averaging. That is why it is the somewhat less than the 184 kmph. But the wind has been defined from the height, local height, to 10 meters to 30 meters above the ground level, up to the 10 meters, up to the 3-storied building. There is no necessity of the taking into the wind force consideration as per the IS 875 Part 3 code only. So the wind has been fluctuated from the 0 to highest percentage. The variations of the wind with respect to time. This is the variations of the with respect to 1 minute. This is the time. This is the wind speed with respect to frequency. Number of times it is occurred. This is the goal. This is the average wind speed taking into the the Belmouth code. This is the only time variations with respect to the velocity. These are the some variations, because when you design into the structures and the stall structures, so many of the factors have been taken into the probabilities taken into the consideration. That is why we are taking into the time velocity, the frequency and average velocity have to be taken into the consideration for design of the structures. And at the same time, there is yes, this is the velocity factor, free stream boundary layer from the velocity wall or the any ground level up to the ground level. The maximum velocity reaches up to the free stream of the wind is the boundary layer. The horizontal component is the taken into the consideration of the wind force. When motion of the wind in the vertical direction or the horizontal direction, the horizontal direction is the only consideration for our structures only. So before that, there are the in India, the atmospheric activity there are two types. One is the rotating wind, the second one is the non-rotating wind. Rotating ones are we have already seen in the cyclones. These are the cyclones where there is the highest pressure variations. We are taking into consideration of the rotation types. In the non-rotation winds, these are the small, calm, and it is the neutral equilibrium of the at neutral equilibrium of the atmosphere. The atmospheric is the inversion or the dynamic inversion, or the second one is the neutral or other things. But we are taking in the neutral atmospheric boundary layer. Because of the neutral, we are not taking into the thermal consideration. We are on the mechanical consideration of the point, only the force and the effects. Differential pressure there. Okay. These are the non-rotating force in the atmosphere. The International Meteorological Department have been given into the some consideration of the Bureau Fort scale. What is the Bureau Fort scale? That calm is the 2 kmph, 2 kilometers per hour. The hurricane is the 117 to 117 kilometers per hour. Because of the moderate gales, 50 to 61 kilometers inconvenience when he is walking, and it is strong gales, 75 to 85 and 89 to 102 kilometers per hour. Small trees uprooted. This is the Bureau Fort scale, internationally adopted for the non-rotating wind speeds. So when there is a rotating wind speeds, like on the east coast region and the west coast region, or in America, there is the Australia, or anything in the Hindu Ocean, or the Bay of Bengal, or Arabian Sea, or the Atlantic, or Pacific, whatever it may be, there is the tropical cyclones on the equator, beyond the equator, up to the 20 degrees to 30 degrees. Degrees 20 degrees to 30 degrees latitude, we are facing in the tropical cyclones. The tropical cyclones have been sustained wind speed of the 10 seconds, or the 1 minute, or the 10 seconds are they taken into the consideration for the cyclonic wind speed, sustained wind speed. These wind speeds have been provided in the Indian Meteorological Department from the depression 31 to 50 kmph to greater than to several severe cyclone. This is the recently we have also come across in the Manda. This type of cyclones have been devastating so much of the financial losses to the government from the last decades, and in the history also we are facing the so much of economic disasters. But the deaths are considerably reduced when compared to the economic losses. But economic losses also gradually reduced because of we are providing in the wind engineer, the advancement of the wind engineering. So what is the spectrum? Spectrum is the unique of so many of the frequencies. That is the wind spectrum. Wind spectrum means wind frequencies. The so many of the wind frequencies have been provided in the one logarithmic scale. When even in our studying in the soil mechanics or the structural engineering, we are providing the semi-log graph. That is a semi-log graph for the calculations of the classification of the soils from the clay and silt, boulders, and other things. These are the 40 mm to 0.2 to 2 mm. That is the various largest variations are providing into the one diagram. That is why we are providing the logarithmic diagram. These logarithmic diagrams have the some log 10 or the log e or the other things, but the logarithmic is providing in the so much of the spectrum. Spectrum means so much of variations combining into the one figure. In this figure, there is the 1 minute, 1 day to 4 days. There is the spectral gap. This spectral gap is taken into the consideration of the for the gust engineering. In this case, there is the only 1 day to 4 days. That is the micrometeorological range, and 4 days to 1 year to 4 days. This is the macrometeorological range. This is the only the terms they are used for the what is the range of the macrometeorological region and micro meteorological region. What is the spectral gap? Spectral gap means there is no variations within the 1 hour period. So there is no taken into the consideration of the weathering. But we are taking into the consideration of the wind for our mechanical purpose only. That is the effects of the wind force and that pressure is variation taken from this spectrum of the spectral gap. In this is the mean wind speed was taken into the consideration the 10 minutes to 1 hour, and the gustiness is the 1 second to 2 minutes. Peak is automatically peak is the peak maximum gust wind speed. In the Indian, the IS 875 part 3 has been defined as the basic wind speed is the 3 seconds of considering the base period for calculating the 50 years of the return period as the 50 years return period. So the wind has been defined in the 3 times. One is the time domain. With reference to time, what is the highest speed of the wind? That is the kilometers per hour or the meters per second. That is first is the time domain. Second one is the amplitude domain, the frequency and the wind speed. The probability of the highest dominance of the amplitude, highest dominance. And the third one is the frequency domain. The frequency domain is this already we are just talked, that is the variations of the so much of the frequency. It is the normalized frequency. The variations have been taken into the consideration of the normalized frequency. The area, why it is taken into the consideration normalized, the whole area is considered as the E. That is the whole area is the 2.135. In case of the Belmouth, it is the total is the 1. So actually the U is Z to T. Z is the difference of the height of the structure or the height of the consideration. T is the variations of the time. The UZ is the mean wind speed. U dash ZT is the turbulence. That is the fluctuation wind speed. The both fluctuation wind speed and mean wind speed consider as the total wind speed, horizontal wind speed for consideration for a design of the all structures, all tall structures, even small structures beyond the 10 meters. So what is the bluff body? There is the two types. In the when we are studying in the theory of velocity, the plates, shells, bodies, and other theorems. The bluff body is the any body which is having the three-dimensional plate is. The plate is known as the any body which has the dimensions of the two dimensions less thickness, but our structures are the bluff bodies. Thickness means the three dimensionals. That is the X, Y, Z. The wind is direction. Wind is passing from the one area to other area, or the wind is stucking. Wind is stucking on the any portion of the body. The wind pressure has been acting normal to the surface. When it is acting towards the surface, it is the positive surface. When it is the negative surface, that is the wakes have been powered on the other side, it is taking at the negative surface. But due to these bluff bodies, the pressure distribution and it is the viscosity of this body, it is not uniform. It is the free body in the atmospheric boundary layer. The boundary layer has been defined and it is provided into the wakes have been provided on the other side of the body. That is oscillations from the towards the front side to back side have been considered. This is the drag force, means this is direction of the wind stream in the direction of the what is the direction of the wind is provided in the where is the wind is flowing in the direction, it is the drag force. It is the lift force, same force it is provided in the on the perpendicular to the fluid direction, but our case it is the lift and the drag forces are the same in the horizontal plane, not in the vertical plane. So the lift force is the lateral forces acting on the body, and the drag force is the Elang force acting on the body, or the force of the force on the building. So this is the atmospheric boundary layer from the 10 cube, 1000 meters, 10 to the power of 4 meters. So this is the 100 meters, 1000 meters, 10,000 meters. This from the 10 power 0 means 1 meter. So 10 meters to the 10 meters and 100 meters up to the 100 meters or 800 meters. There is the variations of the surface layer. The roughness layer. Roughness layer means there is nothing but variations because of the all the structures have been. There is no free flow of the wind. That is of the there is obstruction of the wind. Wind has been circulated among all the directions with the 360 degrees in the sphere in the atmospheric boundary, so that it has effectiveness on the other buildings also. That is why the roughness layer was taken into the consideration in the cities, because there is no circulation and there is no escaping of the wind velocity from the one structures to other structures. The other structures was also the dominant effect of the wind. So bluff body means that is the body where there is the three-dimensional. That is mainly the edges. The edges are the sharp corners where the stagnation point is. The stagnation wind pressure has been transferred, and the separation has been occurred due to the this is the stagnation of the wind pressure because of the velocity, the kinematic velocity, and the transfer to the stagnation point where the highest wind pressure, the kinematic V square by 2G has been converted into the pressure head. The pressure head has been into the stagnation. There is no other direction to flow. That is why the direction of the flow was transferred to the other directions. Where there is the highest direction, vacuum was created. The vacuum is transferred to the separation of the wind layer. That is the boundary layer. Wind from the edges. Because of the sharp edges, the wind was not directly connected to the body, and it is some vacuum is created. The vacuum is considered as the wakes. The wakes is negative energy. The negative energy means that is a suction. The suction means the body was pulling to that side only. Because of this is the shear layers. Because we are taking into the mechanical effects, there is no thermal effects. We are taking in the fluids as the only shear forces only. Like the soil mechanics, we are the shear forces, and the fluids also we are taking into consideration of the shear forces. So before that, going into the Indian context, in the 1956, the whole code was provided the dead load, live load, wind load, and earthquake loads. In the 56, 57 is the first IS 875 code. In the first division, 1964, earthquake code was deleted, and the only dead load, live load, wind load, both three were considered by 1964. In the 1987, these were only the part 1, part 3, part 4, part 5 has been divided into the part 5s, and the ninth part 3 is the wind loads. In the recent revision, 2015, the wind load has been somewhat changes have been taken, and in the 2016 and the 2024, some basic wind speeds have already been changed from the 2015 version to amendment version with the adoption of the National Building Code 2016. In the structural design of the National Building Code, the basic wind speed map was already revised. The revised wind map was considered in the IS 875 Part 3 for the wind loads for the structural engineers. Because of in the 1964, before that, in the 1987, the wind map was the 50 meters per wind map of the 50 years return period with meters per second. That is the 33 meters per second, 40 to 47 meters per second, 44 or 50 meters per second. These are the some zones have been taken into the consideration. Before the 1987, in the 1964, the wind map, the basic wind speed map was considered the two wind maps. That is only the pressure maps. It is the short duration wind map, and the second one is the long duration wind map. These were converted from the pressure maps to basic wind maps of the wind velocity maps of the 50 years of the return period. These return periods have been taken from the 1880 to 81 up to the taking into the considerations of the whole airport to data and other meteorological data. Indian 875 Part 3 code was adopted in the wind speed map in compliance with the other international codes of the ASCE codes, or the ASCE 716, ASCE 702, Australian and New Zealand code. The third one is the European code. Fourth one is the Japan wind code. So the title is the design notes other than the earthquake loads for building structures. This is the title of the wind code. 1 minute. Title has been changed from the 1964 to 2015 or the 875, 2015 or the 1987. Design loads for these are the design loads given for the minimum prescriptive loads to be adopted for a design of the any structure. These are the minimum loads, but you have to provide in the more loads, but these are the minimum consideration loads for considering the design of the any structures. So when we are taking into the wind loads of the structures, there are the two types of design methodologies. One is the static analysis, the second one is the dynamic analysis. Static analysis means up to the low-rise buildings, we have taken into the consideration of the static analysis. The static analysis for the roof structures, there is the roof structures, steel structures, and there is the up to the only the small low rise buildings up to the 10 meters height or the 15 meters height we are taking into consideration of the static analysis. The dynamic analysis means we have to take into the consideration of the gust factor analysis because of the random response. In the code, in this analysis, we are taking into the two types. What is one is the pressure coefficient method, second one is the force coefficient method. The pressure coefficient methods are provided for the external pressures and the internal pressures. That is why we are taking into the consideration of the both direction of the wind, shape of the structure for the external coefficient, the internal coefficients of the consider on the account of the permeability. The permeability means the amount of openings. That is the 5% opening of the doors, or the 5 to 20%, beyond 20%. That is the analysis the code has been prescribed for designing of the walls, individual buildings, or any roof structures, industrial structures, or steel structures. So this is the only equation. The PD and K4 factors are recently adopted in the 1987-2015 window load provisions. Because of the PZ is the pressure variations at any pressure variations any height of the Z 0.6 into VZ square. The VB is the only the basic wind speed. K1, K2, K3, K4 are the wind speed multiplication factors. The wind speed multiplication factor, basic wind speed was given in the 50 meters, 50 years of return period. This 50 years of return period of the basic wind speed was provided in the diagram of the basic wind speed map. And there is the structure, the K1, K2, K3, K4. The K1 is the risk factor. Risk factor means the return period of the design of the structure. Because of the small structures or the important structures or any structures, because of the importance or the type of the structures, type of the probability of structural design, we have to provide it in the K1 factor. Because of the design life is 50 years, or the design life is the temporary structures of 5 years, or design life is considered as the 100 years. Because of the importance, according to the importance of the structures, the risk factor was, risk factor means nothing but it is the probability of the non-accidents, 1 minus 1 by T. We are taking into consideration of the 5 years or 10 years or 100 years of the data. We are considering the extreme value distribution with the Gumbel distribution. We are taking into that. We are taking into the cut what is the highest value of that wind velocity, what is the design period. These both these are consideration into the consideration of the K1 factor. The K2 factor is the terrain height factor. The terrain height factor means because of the terrain. The height factor means height of the structure. What is the height of the structure? What is the terrain? The terrain means whether it is in the city or on the outside the city, in the low side the city, or the in the coastal cities, where is the city is, where is the structure is exposed. That is the terrain. Height factor means height of the structure. So that this is the terrain and height factors has been considered. Third one is the topographic factor. This topographic factor is only for the where there is the greater than the 3% of the slopes. That is only hills. Hillside, when there is the bottom of the hill, foot of the hill, or the top of the hill, where there is the construction of the lines. That is the high tension lines, or the our structures, large structures have been constructed. In case of intended to constructed, we have to provide such type of the K3 topographic factor. But in the India, we are not taking. We are taking in the finally it is terrain where there is no variations of the terrain. That is the flat terrain. We are not taking into the topographic factor. But in case of the foot of the hills or the foot of the hills, near of the foot of the hills, at the top of the hills, we are considering in the topographic factor. And next one is the K4 cyclonic importance factor. This factor was recently introduced in the Indian context after the so much of the elaborations from the 1987 to 2015. There is so much of literature have been considered for adopting the cyclonic importance factor. There are the three coefficient. One is the 1, second one is the 1.15, second, third is the 1.3. Yes. So before that, these are the 6 wind zones have been considered for the basic wind speeds of the 33 to 55 meters per second. 55 meters per second. We are in the zone 5 of the 50 meters per second in the east coastal region. The second one is the 33 meters per second. Highest is the 55 meters per second, corresponding to the 198 meters, 198 kmph. This is in the Kashmir and Kashmir zone and Arunachal Pradesh zone. So before that, this is the taken from the my old steel structures book. This is the 1964 wind map. This is the only pressure wind map. One is the non pressure non. Two types of wind maps have been provided. One is the short duration, second one is the long duration. But kindly see it, up to the 30 meters height, the wind velocity was constant. But presently, up to the 10 meters, up to the 10 meters, it is the beyond the 10 meters, we are considering in the base for the consideration of the wind. But in the 1964, it was the 30 meters. Up to the 30 meters, the wind is constant. These are the three types of, that is 100 kg per meter square, the 150 to 200. This is the old, but it is already not considered consideration for the code, and this is and it is obsoleted. But for the sake of our, what is the actual history as changing from the 1960 or the last 50 decades to present decade, how the wind code or the wind pressures have been transformed. It is the why we are providing in this figure. So this is the wind map. This is the basic wind map. The left side is the 2015 wind map, 2015 wind map. Right side is the 2025 wind map. There is a slight variations in the that is Delhi 44 to 50. In the Delhi has been considered as the 44 to 50 light variations, and some of the variations in the near Hyderabad. This was also the considered from 33 to 44, from 44 to 47. There are the slight variations. The variations have been given in the annexure of the new book. So why we will designing in the from the new book, we have to consider the present design wind speed, not in the not of the previous wind speed. So this is the only from Lucknow, UP, and this is the Delhi. Delhi 4th to 5, that is 47 to 50. These are all the 47 made. Existing basic wind speed is 47, and the revised basic wind speed is considered as the 50 wind speed because of the Delhi, Punjab, UP, Chandigarh, and Manipur, Jharkhand, Madhya Pradesh, Uttarakhand. They are all the north states. North states have been changed from the 47 to 50, and even some of the stations have been reduced from the 47 to 39. That is the Jharkhand, MP, Uttarakhand. Because of the availability of the data, the IS 875 has been reduced from the 47 to 39. But if it is reduced, there is no problem. But it is increased, there is a problem of the two types. One is the existing structures, the second one is the new structures. We have to, first of all, we have to provide the stability of the, we have to check the stability of the existing structure from 47 to 50 meters per second in the Delhi or the Lucknow. And in case of the future structure, we have to adopt the 50 meters per second is the basic wind speed. That is why we have to take it into the new code. So earlier, the classification of structures, the K1 is the risk factor, means the probability of the non-exceedance of the given wind speed. The design wind speed generally taken as the 50 years of the design wind speed. And at the same time, the general structures design life is the 50. It is taken 50 by 50 is equal to 1.0. In case of the 5 years temporary sheds of the boundary walls, they are taken as the 0.67. That is the 5 years of design life period. First is the risk factor. The risk factor has the two parameters. One is the design life of the structure. Second one is the design life of the structure, and the basic wind speed factor. Basic wind speed design area. Yes, that is the 50 years of the basic wind speed consideration of the design life of the from 100 years to 50 years. In case of the 100 years important structures, generally in case of the government buildings, hospitals, communication towers, and important buildings, we are taking in the 100 years of the design life, not for the sustainability of the 100 years of design life, but the probability of the importance of building, probability of the low hazard, we considering the academic and other losses, considering for the human losses, that to design life has been considering in the 100 years, not for the sustainability of the 100 years, even 10 years or 5 years, even first year, it has got into the highest severe cyclone or the highest more than greater than 50 meters per second wind speed has been considered or it is occurred. That is why we are taking into the 100 years of the design life period for the important of structures for the hospitals and the communication towers, not only government buildings. Generally, we are designing our government buildings as the 100 years of the design life period. That is 1.08, 8% better than the original structures. This is the what is the K2 factor in the before that K2 factor in the 1875 there is the class A, B, C. KBC structures have been deleted, only one type of structures, and all the K2 factor have been provided, has been considered for the all the structures without considering the L by B or B by D ratios. This is the 4 types. What is the open sea? That is the coastal area like Visakhapatnam, open country. This open country means 1.5 to 10 meters height of the building structure. Largely more than the 80% of the structures and the range of the 1.5 to 10 meters. In case of the small towns or some suburbans, where there is the up to the 10 meters height of the structures. This is the highest, the city centers, where there is considered as the highest variations on the Z0 means the turbulence intensity. The turbulence is highest in the cities because of there is no escape of the structures. There is a wake have been formed. There is that is why we are taking into the consideration of the cities as been cities are the large cities where about 20 meters height of the building. It is a terrain category of the 4. That is why there is a gradient where a gradient height is very 1000 meters. In case of the open sea, the highest variations is the 500 meters. Because in the open sea, there is no obstacles. That is the freely moving of the air. So this is the reverse of the diagram. This is the 0 to 5, that is the urban, semi-urban, open country and flat terrains. So how the variations of the K2 factor has been changed from the height. This is the K2 factor. That is the equations have been this TC means the terrain category 1, 2, 3, 4. The 3, 4 is the 1, 2. 1 is the lowest highest variations. For the TC 1 is the black is the highest variations. 4 is the lowest variations. Because why height of the gradient height is the low for the open sea, high there is gradient height is the very high for the category 4 of the very in the cities or the city and other industrial areas where there is the highest view ground highest buildings have been considered. This is the variations of the terrain 1, 2, 3, 4. That is the just. This is the table how the variations is 1.05 to 1.35. That is even though 1.05 5% or 35%, but there are the internal forces have been changed into the very much highest percentage. One percentage to these are the input parameters. The output parameters are the bending moments or the torsional moments or the shear forces or the other things. There are the highest variations because of even 2% variations. The stability of the structures have been changed. So this is the already we are taking up to the 3 degrees. There is a hill before the hill or the top of the hill up to the there is the variations. It is much variations because of the stagnation points. This is the stagnation points. Otherwise, is the highest change of the velocity. Why we are taking into the consideration K3 not for the buildings? That is for the transmission lines. Kindly see it. This is the transmission lines. This is the K4, K3 topography factor is highly influenced because in the highest land and the lowest because of the forces has been provided on the one is the highest, second one is the lowest. The highest one is the uplift pressure. Total structure was uplifted and it is collapsed. The lowest structure was simply stable. That is why we are considering this is the K3 factor for the usage in the transmission lines. So this is the recently adopted, and it will considered for the only for the sake of Andhra Pradesh. There are the so many of the cyclones have been hitted in the Andhra Pradesh from the 1960 to 2014, even 2025, even Manda cyclone. But we are not considering the cyclone economic effects. But there are the every year we are facing the one, two or three cyclones we are facing. But there is a now we are in the east coastal region. When compared to the Arabian Sea, we are the most vulnerable region of the 1:4. That is the four cyclones have hit in the east coastal region. One cyclone is hit in the Arabian Sea because of the SST. This is the sea surface temperature. This sea surface temperature is very low in the Arabian Sea. There is a highest variations for the our Bay of Bengal. This is the cyclones, severe cyclones, or very severe cyclones. In this area, we are considering for the 1.15, that is the 15%, and the second one is the 13%. The 15% is increased, that is 1.15 factor is multiplied for industrial structures. The industrial structures means for the economic consideration. It is the 1.3 is the post-cyclonic important structures means this is the lifeline structures. Lifeline structures means highest important structures, even though they are the economic factors consideration, but their collapse or their collapse given into the much of attention. That is why they are taking into the 1.3 in the lifeline structures. That is the hospitals or the telecommunications or any radio towers. These are the essential structures for the life. So these are the some of the cyclone Fani, cyclone Fengal, Dana, Remol, bypass. These are the Amphan. These are the so much of the damage due to the cyclones. So 8.1 billion to 72 millions are the 30 millions. These are the Orissa, Gujarat, in the West Bengal, and Tamil Nadu and Puducherry and Andhra Pradesh. That is why the cyclonic factors have been recently considered in the from the 2015 code. This damage in the affected areas. Even in Andhra Pradesh is not, it is some places in the Krishna and Godavari districts, and in the Orissa, mid Orissa, and the Calcutta. So third one is the Madras. Madras state is Madras, and other neighboring districts was damaged in every year. So in case of the design, what the design's philosophy has been given in the IS 875 code. Simply the design is a building as a whole. We are considered as the building as a whole. Second one is the individual elements, that is the roofs or walls. Because of the industrial roofs, these are the gable roofs or the A-type roofs or the lean-to roofs. Other third one is the cladding units including glazing and fixtures. Fixtures are the highest localized pressurized areas. That is, we are taking into the fixtures as the highest. When we are considering in the roofs or cladding, we are taking into the some of the basic CP and C, that is the pressure coefficient. But in case of the fixtures, the localized pressure coefficient considered to be provided for the fixtures. So this is the only inclined roofs, that is the A-type roofs or the lean-to roofs or the single type roofs or mono slopes. The roofs, the CPE minus CPI means the external wind pressure based on the geometry of the structure. CPI means internal pressure based on the permeability or the opening of the structure. The opening means the total area is enclosed into the walls or facades. The amount of opening means the amount of doors, fixtures, windows, other fixtures are consideration into the for considering the total difference of the difference of the external internal coefficients, so that how much force is acted on the coefficient on the part of the structure. So this is the A-type roof trusses. So how the incidental wind profile, that is the left side is the wind profile, how the wind is acting on the structures. This is the first one is the stagnation point. This second one is the separation point, the reattachment, and it is the wakes are formed on the leeward side. This is the frontward side, this is the windward side, this is the leeward side. That is the reattachment. How the separations, these separations are have taken into consideration. These are the uplift pressures or the internal suctional pressures. The pressure is acting in the towards the top. That is why we are taking into the consideration. These are the CPI internal in the suction towards the top. The right side diagram is the what is the wind is acting on the body, that is the three-dimensional body. How the wind is circulated around the body. These arrows are similar. These arrows are like a wakes. Wakes have been formed due to the stagnation point. These are turning into the top, sides, and bottom. These because of these circulations, side by structures also influenced by the wind forces on the tall structures. Because of the if the two structures are in the equal height, there is no problem. One structure is the tall structure, other structure is the somewhat small structure when compared to other. The small structure has also effect from the tallest structure. These are the wakes and the other interference effects. Wind effects have been dominated for the back structure also. So this is the just sim. The left side is the wind is acting on the body, that is the wall. The internal pressures have been created due to the difference of the wind pressures. These are the highest. These are the highest is the suction. Both on the suction at the top of the structures. That is why we are taking into the consideration for the suction, not in the pressure. These are the suction. These forces are acting towards the top of the sky. In the left side, in the right side also suction, the wind acting from the left side to right side, the suction is also due to the leeward side. The forces were towards the right side. This is why our question is that even wind is acting in the towards the from left side to right side. This is the pressure action. This pressure action has been provided transferred to the right. But as per the model studies and wind tunnel studies, even though pressure is acting, but the suction is more dominant when compared to the pressure action. That is why the suction other side is taken into the consideration the suction wind speed. So this is the history and the present scenario, how the gable end, hip roof, and pyramidal roofs. At the first starting slide, I mentioned that the pyramidal roofs are the pyramidal base. That is in the pyramidal roof. That is the four slopes, four sides of slopes. There is the less circulation of the wakes. This is the less circulation of the wakes. This is the first, the gable end, highest circulation of the negative energy, negative or suction energy has been provided by the wind. The second one is the gable end, somewhat is lesser than the gable end, hip roof, gable end. The third one is the pyramidal roof. This is the both sides. That is the four sides. The slopes are formed in the four sides. In the olden buildings of the government buildings and the taluka buildings, these type of the pyramidal roofs have been occurred in the olden roofs. But in case of our present scenario, we are on the flat roofs and the flat slabs. There is no problem of wind loads for the up to the 3 meters of the 3-story buildings. But in case of the villages or any isolated places, we are to provided this type of the four unit slopes. All the sides of the slopes towards the ridges, pyramidal slopes, so that we have the less wind damage than compared to the other two wind damaged roofs. So this is the left side of the wind has been occurred. This is the why the positive wind pressure and the windward wall. This is the suction pressure. These are the internal positive pressures act with external forces. These are the suctions. There is how the wind the internal wind pressure have been transferred to the highest wind pressure. Even though these arrows are towards the roof end, but the outer side is also giving in the suction. That is why we are the highest wind force, and it is the wind force which is on the eastward. It is the highest wind force when compared to the other ridge or the other sides. In this area, the height of the building before that, the height of the building h by 2, the height by width. Height of the building by width of the building is considered from the three criteria. So up to the 20 degrees, it is the negative. That is the suction pressure. Before the 30 to 45 or 45 and above, the gable wind slopes, it is the positive pressure. But we are up to the 35, the ISO, that is the steel code has given it to the 18 degrees or the 11 degrees or the 13 degrees, up to the 1/4 or 1/5 or 1/3. That is the slope of the maximum slope of the that is the maximum slope of the industrial structures is considered. That is why before the it is the less than the 20 degrees. Thus 30 degrees we are taking into the consideration, that is the EF and other things. This is the highest variations in the windward directions towards U portion. Remaining are the same. So in case of the multiple spans and multiple industrial structures, how the wind force have been changed. The wind forces in the first A and B is the highest forces. C, D, M, N, are the same equal forces, and the last one is the somewhat is the variations. But these are also the 5 to 45 degrees. But now 45 degrees was not considered, but 5 to 10 degrees or the 20 degrees is the only the considered for the practical consideration. But in case of the A and B, the A and B is the highest variations in the starting position. Remaining are the constants. The Z is the, but somewhat is the higher than the inner one, because of the there is no other structure on the right side of the structure. These are the coral provisions. So this is the wind. This is the variations of the wind pressure when the wind is acting from the towards from left to right. In the left to right, the variations of the wind is in the this right to right. All the three directions, the wind pressure have been transferred. That is why we are taking into the wind load as the from height of the Z any direction in the directions of the, that is the previous, that is the leeward direction, sideward direction, or the windward direction with reference to the wind tunnel testings. The CP pressure, external wind pressures have been taken for the, all these are the negatives only. Kindly see it. These are all the suction forces. That is the suction forces, and the reattachment was not taken into the forces. That is why we are taking in the constant of the 0.7 and 0.5 and 0.7. These sides of the 0.7, the rear side is the 0.5. These are the suction forces. That is why we are taking into the oscillations from the wind sides to the leeward side. So in case of the individual frames of the members of the buildings or the any walls or the hoardings or anything, we are taking into the consideration of the only directly force coefficient. Force coefficient is also some type of force coefficient, CF. In the previous CPE minus CPI, that is the external coefficient and the difference of the internal coefficient because of the permeability. But these are the individual members have the no such type of permeabilities. These are the structures we are considering the force coefficients because of the, generally this was considered in the buildings or walls. Third one is the hoardings. So in case of the walls or the hoardings, the CD, that is the drag coefficient, is the because of the height of the structures, the width of the structure. In case of the height of the structures, the width of the structures is 1.5 or the 5 or the 10 or infinity. In case of the height of the structures, the width of the structures is very, it is 1.16, it is 1.12. This is the only variations from the 1.1 to 1.6. Because in the industrial area, the any cities, the hoardings or the signboards have prominently for displaying the all the advertisements. These are the somewhat not given in the not given the consider concept of the concept of the correct methodology of the code has not been already not given in the specified phenomena of the design, but the design was considered for the to avoid the undue variations of the wind loads and undue deaths and undue economic losses. This is one of the in the 2019 have been given in the during the cyclones. This is the one of the advertisement, one of the provided in the for what is the economic and other aspects. What is the hoardings and their effects on the structures or the pupils, or what is the this is the only the 200 kmph or the what is the providing in the cities. So this is the hoarding damages during the Hudhud in the 2014. This is the Visakhapatnam, and these are also Visakhapatnam. These are the hoarding damages during the Hudhud cyclone. These are the hoarding and these are the display boards. So in case of the water tanks, in the petroleum tanks, hoardings, boundary walls, in case of the water tanks also, we are taking into the 1.3. Code has not been given in the specifications of the water tanks, petroleum tanks, but their hazard is very, very high when compared to the normal. But that is why we are taking into the water tanks and petroleum tanks as the 1.3. In case of the hoardings design not is specified in the design, but because of the highest city area where there is the damage damage caused to the human loss or the other economic losses causing, this is also be the considered as the industrial structure or the post-cyclonic important structure, but we are considered as the post-cyclonic structures. In case of the boundary walls, in case of our boundary walls less than 3 meters, we are not taken into the consideration of the 5 years. This is considered as the 50 years of the design. In case of the boundary walls of the retaining walls more than 3 meters, the retaining walls should be considered as the post-cyclonic important structures. It is also 1.3. In case of this is the cyclonic impact and factor is considered for the representation of the loss of the human loss and the structural safety consideration. The cyclonic factor was introduced in the 875 part 3 2015. These are the some of the Hudud cyclones and the Phylline cyclone, Neelam cyclone, Jal cyclone. These are the some database have been taken from the previous cyclone database from the 2012 1989. The Jal cyclone, even 2010, Machilipatnam, Divisema, 1996, Kakinada in the 2004. So, and various districts of the Nelluru, all the district coastal districts have been hit by the different types of cyclone in different areas. So this is this is 1 by 1/3, 1/4, and 1/5 are the 3 types of the roof slopes. Standard slopes were considered in the design of the steel structures. That is the 18 degrees to 11 degrees. That is why we are taken into the 20 degrees, 20 degrees only. We are above the 20 degrees to 30 degrees. It is the some positive pressure, but we are not considering the positive pressure, only suction pressure. Code has stipulated for the 3 types of the roof slopes, 1 in 3 and 1 in 4 and 1 in 5. 1 in 3 is the steepest slope, 1 in 5 is the flat slope of the 10 degrees to 11 degrees. That is why we are taking into the live load is the one in case of 750 minus 1/3. Some equations are given in the 10 degrees greater than 10 degrees less than 10 degrees for live load in the that is the slope roofs. So in case of the gust factor, up to this level, we are talking about the only the static method of consideration of the design. In case of the gust factor method means height of the structures. That is the code has given in the low-rise buildings from the less than 20 meters. And 20 meters to 50 meters, greater than 50 meters, high-rise buildings. So 50 meters to 20 meters, medium-level buildings. But the medium-level type of the wording was not specified in the code ISO 875, but it is the above 50 meters high-rise buildings. These are all the, not only high-rise buildings means not only buildings, but it is the telecommunication towers, all the towers, not only telecommunication towers or the transmission line towers, or the any towers which are the steel monopole towers or the street light towers. Anything greater than 10 meters is the high-rise structures. There are the oscillations of the structures have been predominantly considered for the design of the structures. So this is the wind direction. When there is the wind is directed, when the wind is acting on the any body, there are the three types. One is the alongside, there is the crosswind. Third one is the torsion. The crosswind and along wind are the same plane. The along wind is the drag forces. The crosswind is the lift forces. The lift forces and the drag forces on the same plane. Not in the type of the aerofoils. Aerofoils is the drag force is the horizontal and the lift force is the vertical. But in the building consideration, the crosswind is the along wind is drag forces, the crosswind is the lift forces. But these are only horizontal plane only, not in the vertical plane. And the third one is the torsion. Torsion is already variations of the wind forces and the variations in the from left to right or right to left or the east to west, any direction, it is the unbalanced force. So this is the one type of the variations of the reduced spectral density of the both the what is the wind spectrum and earthquake spectrum. The earthquake spectrum is the frequency, wind spectrum is the period, time period. We are taking into the period of the 10 seconds, 1 second, less than 1 second, 10 seconds. Wind is oscillation from the 3 seconds. What is the we are taking into the basic wind speed? This is the averaging of the wind speed for the 3 seconds period. But in case of the earthquake, that is 0.6 seconds. 0.1 second, there is 1 hedges or the 5 hedges or 6 hedges. There is the 10 hedges. 0.6 seconds. There is a response spectrum factor given in the 0.1, 0.2 or the 0.6 seconds. That is the highest frequencies. There is a earthquake the frequency is the highest. Wind frequency is some low frequency. That is why we are taking into the seconds time period. The earthquake is in the hedges. That is the basic difference between the earthquake and the wind spectrum, wind spectrum and the earthquake spectrum. So in case of the gust factor method, there is the highest, there is a greater than 50 meters, 50 meters height. There is the variations of the height, variations of the consideration of the Z, variations of the level at which we are consideration into the for knowing the forces and movement. This is the gust factor. There are the two types of. One is the back. One is the frequency variations. Second one is the background variations. Background variations is the GV or the BS is the background variations, slowly varying, mean wind speed. There is the second one is the frequency variations. There is the gustiness variations. The where there is the highest variations of the spectrum with reference to the resonance factor of the natural frequency of the natural frequency of the building and the frequency of the wind has been considered for calculating the both are calculating for finding the gusty G value. This is the G is the CF and the AZ into PZD. Well, G is added in case of the gust factor method. In case of the non-gust factor method, CF into AZ into PD is the force coefficient method. There is the only difference between the gust factor method was added. But in case of gust factor method, the basic wind speed was taken into the consideration 10 minutes, not for the 3 seconds. That is why mean wind speed was taken into the consideration for gustiness. This is the just variations, how the variations of the wind speed from 39, 44, only 47, 50, 55 was not considered because of it is only in the that is Srinagar and other areas. These three, the 33, 39, 44, 47, 50. These are the how the variations with the height of the variations. That is the this is the Newton per meter square. The horizontal axis is the Newton per meter square. The height is the height of the structure up to the height of the structure up to the 40 meters or the 45 meters. How the variation? This is the logarithmic variations, base log variations when compared to the power variations. The power variations and the log variations are same, but the logarithmic variations is the theoretical basis. Power variations are the empirical variations. The empirical variation, the power has been changed from the 1.00 to 1.75. Whatever it may be, we are the empirical variation based on the experience we are provided. But theoretically, the logarithmic variations of the log E is the Z by Zn. Log E whole to the power of Zn is considered for variations of the wind load with respect to height. This is also same for all the basic wind speed from 39 to 50. Recently, it was changed from logarithmic from one zone to other zone. This is under draft. This draft was not directly implemented. The code will be new amendment code will be published within the 1 or 2 years. So this is the gustiness variations. What is the gustiness variation from the? This is the one of the PhD studies from the 1980 when compared to the 1987 to 2015. That is K4 factor 1 and 1.15 and 1.3. How the variations are gustiness variations in case of the 2015. The K variations is the from the 2.5 to 3. In case of the other sides, these are the somewhat increased from the 2.5 to 3.5 from the height of the 30 meters to 5 meters. This is the only step by step. Not it is considered as lowering or the hiring, but it is variations with respect to where we are considered. In case of considered 5 meters, what is the gust factor? In case of considered it is the 10 meters, what is the level of gustiness? From 10 meters to upper, higher level. In case of the 80 meters, what is the gusty level? In case of the 0 meters, highest level. In case of the 0 meters or 5 meters, the variations is the 3.5 or the highest, because of the highest turning forces have been considered. Because of the tall, this is the 100 meters height, when there is considered the 100 meters as the base, there is no gustiness. But in case of the gustiness, because of the gustiness, overturning moment, torsions are considered at the base only. That is why in case of the 0 level, these are highest when compared to the highest levels of the 30 meters. So these are the some of the variations of the wind pressure from the old code to static code to dynamic code. In the right side, this is the static code blue. This is the highest. This is the light to green color is the variations of the gust factor, gustness VZ factor when compared to the wind pressure with reference to the with reference to the static code. That is the gustiness factor. The gust factor method was considered when compared to static method for the long or the high buildings or the high rise buildings. So these are the some of the telecommunications towers we are considered for the. This is the one type of telecommunication towers. These are the only from 10 meters or the 30 meters or the 40 meters. So we are considered for the wind loads are the highest. There is the porosity, solidity ratio was considered because of the upstream wind speed and the low downstream wind speed. There is the highest of the porosity. That is the solidity is very, very less because of the wind is flowing from the upstream wind direction to other directions. But some allowances have been taken for consideration in the upstream and the downstream. These are the highest vulnerable wind sensitive structures. So this is the one of the Varda cyclone 2016 when I was in the 2014 PhD. These were considered as the some of the one case study to study what is the cause and effects of the Varda cyclone during the three-legged towers in the Madras state. So this is the cascading effects. In case of the electrical levels, one line or the one pole was struck or fell down. The other poles were also down because of the cascading effects of the lines. Here, there are the two important points. The line is the line or the the factor of safety of the conductor wire is more than the factor of safety of the structures. That is why the structure, in case of the one pole is damaged, other poles also not, other poles are damaged, but the wires are not cut into the two pieces. That is why we are considering, we are part and parcel of the that is the high tension wires in the PhD and the other person, other friend, we are studied that type of the structure. 802 code has been given in the factor of safety of the wires is more when compared to the our steel poles. That is why cascading effect was always affected with reference to the poles. So we avoid that cascading effects. The structures have been designed in such a way that the cascading effect should not be affected. So this is also one of the cyclone, some of the rooftop structures, not in the ground-based structures. This is the rooftop structures. Even rooftop structures of the 10 meters or 15 meters or 5 meters or 8 meters. This structure was damaged due to the variations of the wind during the cyclone. So in case of the buildings, tall buildings, there are two types of structural design, architectural design. Third one is the mechanical design. In case of the structural design, we are providing in the shear walls or the bundle structures tube structures, outer tube structures, outer rigger structures. Such type of structural elements was constructed for the building of the structural engineer considered. In case of the architectures, these are the plan of the architecture. Plan is considered such type, so that wind should be the moving freely without affecting into the without any waking on the structure, so that the wind, the load, aerodynamic wind load should be the considered for smooth variations of the wind. This is the first basic diagram of the plan diagram. This is the fins. Second one is the corner cutouts, slotted and roundness of the corner, throughout opening, corner recessions. These are the types of the plan variations, plan structures, variations of the in the plan direction, so as to reduce the wind load on the structure. In this case, there are the three types of the dynamics. One is the aerodynamic, second one is the structural dynamic, third one is the flight dynamics. What is the aerodynamics? Air interaction with the body is the aerodynamics. Structural dynamics. In this aerodynamics, air and the body, that is the fluid is, that is the air is on the considered as the body. Second one is the structural dynamics. Structural dynamics means the dynamics which are considered inertial property of the body is considered as the structural dynamics. The structural dynamics are considered mainly for the earthquake. That is the earthquake means the displacement method, and the inertial force or the gravity force was consideration. It is the structural dynamics. Third one is the flight dynamics. Flight dynamics means the free rigid body, the whole rigid body, like a aeroplane, that is the rigid body flowing into the stream of the flowing into the stream of the air. That is the rigid body movement in the air. It is the flight dynamics. These three dynamics and these design philosophy of the three dynamics have been different from one to other. We are in the aerodynamics. Aerodynamics for the any body or the bluff body. Bluff body means our buildings having the thickness. That is the B, L and D thickness is taking consideration of bluff bodies. These are the force diagram. Second one is the building. What is the earthquake? That is the only the displacement. Third one is the rigid body movement. The body, whole body is considered as the rigid body without any distortion in the fluid dynamics. In the olden columns, the columns are considered as the hinged columns. One one edge is hinged, other edge is free, other the both edges are free. The both edges are the free. When we are studying in the diploma engineering, we are not understanding why the both edges are free. That effective length is taken into the L is equal to 2L. That pi square A by L square is equal to somewhat is equal to 50%. That it is the rigid body. The column or the both ends are free. That is the rigid body moving into the stream of the air. That is three types of the dynamics. So this is in this case building aerodynamics, air and the wind and the body interaction. This type of the interaction we are considered. This is the plan variations. These are the architectural variations we are considering for the reducing the wind force. So in case of the tall structures, in case of the stall structures and flexibility structures, in case of the L by B ratio is equal to, that is the long columns, the long columns and short columns. In case of the long columns, the force is reduced to 1.05 and the stresses are very long when compared to the small short columns. That is in case of the small flow induced vibrations, we have to provide some weight or some wind induced, we have to reduce the wind induced vibrations. We have to provide some methodology to reduce the wind oscillations so that the rigidity of the structures would be ascertained. Because of the three, this is the one is the long structure, second one is the wind turbine, third one is the horizontal wind pipe. These are the structures. This how the forces, the magnitude, time lag in case of the velocity, density, external closure or the turbulence. This is the natural frequency, how the variations of the masses and damping. These are the considerations for the flow induced vibration and mitigations also. Where you have to be provided on the some type of the structure, how to provided in the damping, how to the mass distribution and the vibration amplitude. The damping is already inherent damping Q of the 5% is taken in the 2% to 5% based on the previous studies of the all the structures. But in case of the long flexible structures, the damping should be provided in the somewhat in the middle type. We have to provide some weights so that the oscillations are reduced. So this is the top of the structure where we have to provide some weight so that the oscillations were reduced. This is the Tacoma bridge due to the alternative vortex. Alternative vortex means left side and right side. This is the right side. This is the left side. Somewhat variations. These variations causes the continuous variations causing the damage of the structures. These are considered and these are occurred as the continuous, and it is reached to the natural frequency of the structure. When there is reached to the natural frequency of the structure was collapsed because of the resonance was taken into the consideration. So flow separation. In case of the, we are reduced the aerodynamic forces. It is reduced the aerodynamic forces, extra momentum to the fluid that is provided in the weight or delaying the shear layers that is in the base area considered in the some slots or in the plan area, or in case of the that is the sectional area, we have to provide some porous structures so that we have to reduce the flow, that is the stagnation pressure on the structure, so that we are safe against the wind. There are the two types of controls. There is a passive control and active control. The passive control means geometric modification. We are providing in the plan geometric modification, or the there is the elevation modification, or the other type of the porous structures. We have to provide it in the so much of the architectural variations based on the that is wind tunnel test, wind tunnels procedure. In case of the active control, we are provided with the aid of the external energy. External energy means we are provided in the mass tune dampers or the some of the dampers, SKS fluid dampers. There is the bracings we have to provide, or the base isolators. In case of the earthquake, we are provided in the base isolators. In case of wind, that is not provided because of not much of that necessity is there. Only we are provided in the some type of wind, that is the tuned mass dampers. that is the master tune dam plus either it is provided in the top of the that is 100-story building, so that wind is hitted on the one side, the mass is oscillated on the other side, like it is a pendulum, so that the oscillations is number of oscillations is reduced. So this is one type of the what is the basic theory, a golf theory, when it is the free in the smooth sphere, and there is the pimples somewhat dented sphere, dented golf ball. In case of the dented golf ball, the boundary layer of the thickness of the wakes is very less, and this is the going into the long distance. In case of the smooth ball, the wakes are formed in the wakes are highest forward. It is not going into the destination. That is why we are provided that type of the physical physics was considered for the design of the not only spheres. In case of the cylinders or the rectangular structures, other structures, we are provided in the engineer. We are provided in the our buildings also. So this is the dimples. How the dimple has the otherwise, what is the curve, what is the aerofoil, what is the shape of the aerofoil, how the free force of the air was freely passing without any suction effect or without a suction effect, or without any damage to the, in case of the suction, it is the pitting effect. In the same pitting effect, we are in the, even the hydraulics, we are provided in the larger area to reduce the vacuum pressure to the positive pressure, to have the high, increasing the pressure, to have the reduced the velocity, to provide the, to avoid the pitting effect. Same situation in case of the, our aerofoils, our building also, in case of the suction effect, our building was damaged. To avoid the suction effect, we have to provided such type of the geometry, so that the suction should be the very less. So these are the type of the vertex generated. In case of the vertex also, when the wind is flowing from one direction to other directions, not in the flow, some dent marks or the some rectangular or the parabolic dent marks have been provided, so that the wind was not in the free flow, no suction have been happened, some incident of wind was interrupted, so that the blades or veins are some triangular or the rectangular fins provided, so that the suction was not happened, and at the same time wind is freely flowing, and that aerodynamic effects was reduced. So this is also control flow, that is this is the ship or the aerodynamics or the aeroplane, how the wings and the boundary walls and the vertex air force boundary layers and the boundary layers attachment, reattachment, same philosophy was used also our buildings also. This is the flight dynamics we are using in the aerodynamics of the buildings. Same vertex generate. Vertex means there is the vertex means a free vertex are there, that is the rounded. It is the free vertex or the forced vertex, the variations of the wind flow around the building. So this type of the, in case of the long smooth building, smooth wire or smooth any smooth wire or any column, any things, this was given into the wake and the downstream section. In case of the some curlings or the some of the distortions, several geometric modifications, helical stacks, wave stagnations, sinusoidal axis, hemispherical bumps. In case of the bumps are provided, the wind speed or the wind velocity variation with respect to time is increased. In case of the wind velocity with respect to time is reduced, wind is highest variations causing the effect. In case of the wind flow around the body is increased, so that the effect is normally reduced. So that such type of variations of the other geometric modifications were provided for reducing the wind forces on the structures. So this is the building aerodynamics. In case of the normal building flow, constant velocity flow, no variations, no wind pressures are occurred in the left side. In case of the right side, kindly see that because of the boundary variations, because of the frictions, because of the shear, the variations of the wind was all the directions, even the from middle to boundary. It was inclined to the boundary, and it is reattachment from the right side to left side and in the back side also. That is what the downwashes. So in the absence of downwashes, square of the because the wind is the variations of the wind is the square of the wind elastic. Because of the 0.6 into Pz is equal to 0.6 into Vz square. In case of the small variations, the square of the pressure was created. That is why in case of the small variations of the wind, the pressure is increased in the square. So that we are utmost care while consideration in any of the building, even small variations also. That is why in the 44 and 47, 3 meters per second, that 44 and 47, but there is the 47 is the highest variation when compared to the 44. So these are the some type of the wind flow region around the tall buildings, because stagnation point means highest point where the velocity is converted into the pressure energy. It is a wake situation. Wake means the negative energy. That is the suction energy. Flow separation. This is the underline, the sideline, and the top line. All the around the building, the variations of the wind was considered, and the building was taken into the consideration all the forces, not only in the perpendicular to direction of the forces of the wind. This is the top force, side forces because of the side oscillations, top oscillations, all the three movements and the three forces. That is the 6 dimensions, 3 into 3. That is X, Y, Z. Three movements and three forces were consideration: pitching, yawing, next thrust, drag, lift, all the rolling, all the directions, all the variations of the movements and the forces were consideration while designing of the building. So this is the how the way when consideration of the building. This is the vertex flow. Vertex flow means variations of the above around the circle. This is the through flow, corners flow. Because of the corners, there is the variations in the suction forces. In this is the backside also. There is also a suction. This is the through flow where there is the opening. In this opening also the wind was flowing from the upstream side to downstream side. Because of the vertex flow, corners flow, through flows. Through flow means directly flowing from the upstream to downstream with respect to the openings. These are the corners and these flows are also be considered for consideration of the design of the building. Design of the tall buildings. Even the building is rigid, when the H by L is less, the H by L is less than 5. This is the H by is less than the 5. It is rigid building. H by is less than the greater than 5. It is the flexible building. But in case of the tall building and the flexible buildings, we are taking into consideration. These are all the gustiness factors of the winds. So this is also same vertex flow, and this is where. So already this is. So it is how the variations in the from the variations, cross-sectional variations. This is the Burj Khalifa and 830 meters, and the Shanghai Tower 630 meters, Shanghai Finance Towers. These are the small. Kindly see it. In the up to the some levels, buildings were considered as the solid structures. Beyond the higher, beyond the top, these are the porous. Porous means wind flow was flowing from the one direction to another direction. Kindly give the some access to the winds. So first one, varying in the cross section from the trapezoid or from a bottom to top. Somewhat the spoils, we are providing some of the weights at the structure. And in case of the twistings, setbacks, step backs, these are the types of the so many of the buildings. How the buildings are provided in case of the plan, in case of the sectional variations also. Kindly see that in the top of the building there are the some some points are provided. These are the porous buildings or the porous portions where there is a variations of the wind was considered in greater than the other forces. That is why at the top of the structure they are provided in the some porous structures. So this is also basic how the variations in the cross-sectional variations, the tampering, setbacks, or openings were provided. In case of kindly see that the tall buildings where the foundation design, the foundation variations. What is the 75 meters by 75 meters? What is the how the outrigger design or the bundle structures or the other structures? How they are the provided basic foundation design was given in this structures. This is the left side structures, Jiang Towers in China. This is the Malaysian towers, twin towers. These are the twin towers. Out. This is also outrigger structures. This is the one type of the name of the types where there is a outrigger structures. Next. So this is the spire. This is also already we have discussed. See, this is the pyramidal structure. See, this is the pyramidal structure. Kindly see it. This is the 120 degrees of plan area of the 120 degrees. See, that is the where there is a pyramid has been provided for construction of the. This is the Burj Khalifa of 830 meters. It is the 41 to 50 meters of the width of the one of the side is the 50 meters. So center is the 17 meters. This type of the structures was considered for the wind load, and not only wind load. This is the also for the earthquake load. But we are considered in this lecture. We are considered for the wind loads only. This is the left side is the some facade we are providing in the porous structures. This is up to the structures. This is up to the solid structure. The spire is the only the porous structure which are provided to stabilize the structures for the reducing the wind loads. These are the different types of the outrigged or the tall structural formation in the cross-sectional area where we are to provide in the cantilever type rigged structures or the supported structures to reduce the wind loads on the structures as well as the stability of the structures, not only for the wind but also for the earthquake also. So this is the type of the sum of the Burj Khalifa to just variations from the how the variations from the Petron towers in the Malaysia to the Burj Khalifa towers in the variations of the fits are the 830 meters to 300 meters. This is the type of the structures. This is shown like that how the various types of the architectural variation, the cross-sectional area and the elevations were considered for reducing the wind forces. These are based on the what is known as the wind studies in the wind tunnel studies. Wind tunnel studies have been provided in the SCRC and the RWDI, some IIT Roorkee and IIT. So many even in the aerodynamic forces, IIT Hyderabad recently have provided wind tunnel testings also for the drone studies. So this is the one type of the how the buildings are porous and the buildings are architectural frames to reduce the wind forces. These are the just we have shown it when we are providing in the diagram. It shows the more impact than the theory. That is why we are providing the so much of diagrams, so much of collections, so that different types of collections how they are modified in the actual real life was constructed in the all around the world. So this is the CFD diagram. CFD where the how this is the Hyderabad where there is the in the Hyderabad where our EN's office around the EN's office there was a structure which was more than 25 years. Same that in case of the one of the research papers we have taken into the consideration these pictures of how the variations of the wind from left to right in case of the CFD models. Not only for the traffic, only CFD models, neighboring structures was affected. This is the one of the CFD model we are taken into consideration from the one of the research paper. So this is also somewhat Burj Khalifa and other structures. So this is the plan area. This is the wind action. This is the plan area. How the plan view of the slots, plan view without slots, how the attachments and reattachments were done in the both the structures. So that the see up to the some type of the structures. This is the solid. Before that, above that, this is the only porous structures providing the wind flow from the middle of the structure, so that the wind is free flowing from the one side of south side, so that the how much of the wind is reduced, how much of the height is increased. That is a consideration for the stability of the structure. So this is a
Thank you, sir.
Alex.
Thank you, sir, for your enriching talk on sustainability engineering. Your examples of eco-friendly structural design were truly inspiring. Now we'll proceed to the interactive question and answer session. Participants, anyone have any questions can unmute themselves or post any queries in the chat box.
Sir, good evening, sir. Santosh garu.
Sir, good evening, sir.
Sir, the session is very informative and the subject is very dynamic, sir.
Thank you, sir.
Yes, subject is dynamic in nature. Thank you very much, sir.
Thank you, sir.
Participants can unmute or post the questions in the chat box. Sir, there is one question, sir.
Okay, madam.
What is the height of the structure above which wind load must be considered without fail?
Without
Fail.
fail.
Yes, sir.
No. First, the wind load have been taken for consideration, not the failure. The minimum wind loads have been provided for consideration of the structural stability from up to the 10 meters. Before 10 meters and up to 10 meters, there is no consideration of the structure, consideration of the wind. Beyond the 10 meters, we have to mandatorily consider the consideration of the wind loads, even for the rigid structures also. The code has been stipulated. Be above the 10 meters, we are check the stability of the structures for the wind loads also. Above the 10 meters, it is mandatory. Up to the 10 meters, that is the 3-story buildings from the ground, it is not necessary. But above the 10 meters, even the rigid structures, even 5-story building or 6-story building and 10-story building, 10 3 is equal to 30 meters. Even 30 meters, it is the rigid story because of the L by B is equal to less than 5. But in case of the rigidity also, we are mandatorily once again check the wind loads, both on the individual members as well as the structure as a whole. And second one is first is the alongside and across side. Second one is the interference effect by the nearby structures, and at the same time future variations, future up to the next 50 years variations should also be consideration for design of the structure. It is implicitly taken for the given in the book IS 875 part 3 also.
Any more questions from the participants? Please post your questions in the chat box. Would you please send me PPT, sir, which it's
Okay, madam.
chat
Okay, madam.
in the
Inka
participant side, sir.
no. Some 10 to 15 slides is also there. There is one thing is the rubber dam is the water harnessing. There is one thing. This is one thing, madam. Can you see my video?
Yes, sir.
This is
Video, sir.
you see what I am taking in my hand. This is the rubber dam. This is the Asia's largest rubber dam in the India and Asia. This is the Janjavati project. This is the rubber dam. This is the rubber It is the 16 mm thickness. It is the 3-ply thickness. It is the bulletproof rubber dam, madam. 2004 it was constructed and it was recently the Austria team visited. That is why we are taking, I am working recently, I transferred in the Parthipuro. I taken that material which is the force taken into the consideration to show our participants. This is the 16 mm. This is the one of the no damage from the 2006 to 2026. That is the only, this is the bulletproof material, but it is the only the type material. This is the only, this is just consideration of the. This was also working. Okay, madam. Thank you for your
Shall we conclude,
that
sir?
Bollaya College and AICT and other persons who are participated in this lecture also. We are also thank you for all.
Yes, sir.
Your
We
principals are
sincerely
your
appreciate.
DTP Naid sir, your side.
Yes, sir.
We are also
Yes, sir.
very glad to for this type of lectures and this type of FDPs.
We
Namaste,
sincerely
madam.
appreciate, sir.
Namaste, sir.
Appreciate your time and effort, sir. You devoted to share your valuable insights and expertise with us. The participants have undoubtedly benefited greatly from your enlightening session. On behalf of the organizing team and all the participants, we express our heartfelt gratitude for your informative and inspiring presentation. Thank you very much, sir.
Thank you, madam.
With this, we conclude today's day 3 session of our AICT ATAL Faculty Development Program. We sincerely thank our esteemed resource persons and all participants for their active involvement throughout the day. Our
Thank you,
ATAL
madam.
faculty will resume tomorrow with day 4 sessions, promising another round of insightful talks and meaningful interactions. Thank you, everyone, for joining us today. Wish you all a wonderful evening.
Thank you, madam. I will
Thank
send
you,
my
sir.
PPT also, madam. I will
Yes,
share by mail, madam. Thank you.
Yes, sir. Thank you very much, sir. Participants are requested to fill the feedback form